All right, welcome everybody. Tonight is the 5th of October in 2021. This is the Dallas Personal Robotics Group, Robot Builders Night Virtual. And we just go around the table talking mostly about things related to robots, mechatronics, software, algorithms, things in that nature. But you never know, sometimes the topics veer into more amusing areas as well. Just a brief intro before we do our normal roundtable thing. Talking about upcoming plans or gaps in the plan. Just curious, did anybody last weekend happen to do the hackathon? Hack DFW, raise your hand. Okay, nobody did that. All right. I know that somewhere in October is supposedly the Seattle Robotics Society holding the second virtual Robothon exhibit. Doug D, are you going to do that still?
I heard that was in November.
Oh, right. On the website it lists October, but I don't know. It's October, November. I don't know.
I'm hoping it's November. I'm not ready.
You're aiming to get in there, right? Do you have a date yet?
I have not had a date, and I actually haven't talked to them about it, other than just during the meeting. I said I was interested.
All right. So there's a few of us keeping our eyes to it, and when it firms up, we'll share that information around. But then lastly, and this is what I'd like to chat about in a half an hour or so, 45 minutes. We're looking for speakers for this coming Saturday, and then November and December. So if anybody just happens to have something they want to talk about in 4 or 5 days from now, bring that up when I come back to this. If you don't, I have an idea that I'll raise when we get to that point. But with that, my name is Carl Still for another few sessions, the current president of DPRG. And I'd like to kick things off by introducing whoever's going to talk next. And we happen to know that Ray is going to talk about BAM, binary angle measurement. And then after him, we have Scott and Ian and Pat on different topics. And then after that, it'll be a free-for-all. So think about what you want to talk about. Think about what you want to present. And in the meanwhile, I would hand the floor to you, Ray, and let you take it away.
Sounds good. Okay, that's working. Okay. Is that big enough so that you can see it, the text? Can you make out the text?
Can anybody not read that wants to? You're good, Ray.
Okay. Anyway, I was kind of curious about the binary angle measurement, trying to find a kind of a foolproof way to do what BAM does, and kept putting off looking at it and trying to figure out other ways to do it. So what it is, basically, you're representing 360 degrees with a fixed width binary number. You can do it in, I've seen it done in 12 bits, 16 bits, 32 bits. You know, of course, the more number of bits you have, the finer resolution you have. You know, with you know, parts of an angle. So you can go down to, I think it was 16 bits. It goes down to like, I think 0.0055 degrees, which is pretty small. Anyway, so to do it, I basically created an array called bin, and so to get it to represent angles between 0 and 359.999, 360, I guess. You set the most, or weight the most significant bit to half of the range of values that you want to cover. So that's 15. This little for loop propagates the rest of the array. And each next smaller bit is half, just like with any binary number, but it's it's associated with the weight. So it starts out, and this thing will print out here. Serial monitor. Gotta hit reset. Okay, so it spit out a huge bunch of numbers. Okay, so this is the contents of the array that I use to just store the values of the weights, basically. So 15 was 180, 14 is 90, 45, and so on, all the way down to 0.0055. So that's the smallest amount that you can represent with the numbers. Then I just did a for loop and ran from 0 to 360, and these are the numbers out of BAM, or what I'm calling BAM. So 179.99. I had another method to do it, which just uses integers. It comes back with 180, and these numbers agree all the way through, the range of 0 through 3, through 360. And let's see here what it did. I basically created two functions, one to, and I'm sure there's quicker ways to do this with other, for loops or other loops. But so this function actually converts an angle to, the binary angle measure form. And what it does is it just figures out, you pass it in a float, and it tries to figure out which bits it needs to set to represent that number. And in most cases, you're going to have, it's not going to represent it 100%. You're going to have some remainder left over, but the smallest weight is 0.0055. So you come out with some, pretty numbers that are pretty close. And you can use the round function if you really want an integer and you want to convert like 235.9918 to 236. So this function converts, a float to BAM, and then another one does the reverse. It takes in, converts a BAM to a float, basically. And if the bit is set in the binary angle measure representation, then you have to add that quantity back in to get it. So if it's say the number was or this most significant bit was set, that means you have to add 180 to the angle, and so on. This would add 90 to the angle and 45 to the angle, and you keep going on down to you've covered all the bits that are represented, and it just returns whatever the float was. So in a for loop, what I did is just and here's the extent of the for loop. It just and initially I thought it wasn't going to work to subtract angles, but I actually realized what I needed to do if it was less than 0 is to take the absolute value of the number and subtract it, and that works fine. And sums work okay too. So this is always going to produce a number between 0 and 360, because that's really what you want. That's what you're getting off your compass. So if you're looking, say, to rotate counterclockwise, you could add whatever quantity to like an initial heading to get that rotation or shift. And if you want to go clockwise, then you would subtract it. And so that's what, let's see, okay, BAM, sum, yeah. So this just converts them into binary angle measurements. This converts it back, and this just, prints out what the index was, in this case, 0 to 359. I did another function that produces it does produce the same result. And it only requires a few lines of code. It'll accept negative numbers for the offset here. It works just fine, and it also returns, the integer, basically equivalent if this number was rounded up. That's, if you can't see it, it's 232.9926, and this one, it produces 233. So that works pretty good. The other thing that I really needed was to get the difference between two angles. Like if for steering, to add like an angular measurement. In this case, I'm moving a certain number of centimeters, but with guidance with a compass. So it's basically moving so many centimeters with a heading. And it needed, basically the difference in the two numbers. And, just did this function to produce the minimum distance between the two numbers, because that's really what you want. You don't want to go, if you can make a shorter rotation, it's better to do that than to make a long rotation around, say if, your target was actually 355 degrees, but your compass was reading 5 degrees. You really just want to go counterclockwise 10 degrees. And that's what the calc difference function does. And that's what these numbers are here. So I set the target to 180. And this should go, yeah. So at 180, it flips and tells me that, okay, now I'm, 181, negative direction, that means I should really rotate counterclockwise. And a positive, I think, is clockwise. I think I'm reading that right. Anyway, so that's kind of what I've done with BAM. Like I said, you can represent a BAM number with more bits if you want higher accuracy, but it seems to work pretty good. But creating this function, it does basically the same thing with integers, using the map function to give you the correct angle, that's equivalent to using the binary angle measure. So
remind us why you need this. Is this for performance?
Well, the the only readings you're going to get off the compass, at least the B&O 055s, you don't get 0 plus or minus 180. You get 0 through 360, and 359.99. But if you're dealing with angles that are on either side of that transition, it's just a little difficult to keep that all straight. Like if say like adding two angles together. Say you have one heading, and now you want to change that. Say you want to add 90 degrees to it. You can simply add it, and it will give you a number between 0 and 360. So that's, as you rotate, that's the range of numbers that your compass is going to give you back. So it's just easier to have to deal with that versus, you know, some other method. You know, it's just you put the two numbers into either one of those two functions, and you get the number back that your compass is going to, you know, basically tell you you're moving towards. So anyway, so that was all that I had. It was kind of interesting to look at. You know, there's tons of stuff that you know, it's like in a lifetime, you know, I don't know if I'll ever look at it all, but I'd wanted to look at this for a while, and finally took the time to do it. And
You were hinting earlier that you found some places where it's used and examples.
Yeah, apparently it's been used on ships quite a bit. The you know, if you're trying to transfer basically measurements, you know, because ships have compasses, they need to steer around things. So it basically, to transport whatever those readings are, apparently this is what was used. And you know, it gets rid of the issue. You know, they also have servos that you know, may need to be positioned in different angles, so it's useful for that. So that's, you know, that was one of the examples that I'd seen. Apparently for ship guidance, it's been used for quite some time. I don't know how long, but you know, those types of servos have been around. I don't know, maybe, I don't know, probably as far back as World War II, maybe further. I'm not certain when servos actually came into, digital servos at least actually came into play.
At TI, when they were doing the harm missile, they did things in bands because that worked out better.
And that was the 80s, if I remember right, Dave?
Probably
Yes,
maybe.
that's right.
Harm was the 80s.
Yeah. Anyway, so it was kind of neat to see it, and
All right.
so it's
Hey, Ray, while you were talking, Ted had a thought. Ted, is there a chance, could you elaborate on what you were thinking about simplifying, ways to simplify what you saw?
Yeah. So I just wanted to point out that it's really not that complicated. It's just a unit conversion. And so you could kind of think of it as a fixed point number. So like if it was an 8-bit, you'd have 256 degrees, well, not degrees, but units around the circle. So it's just 360 divided by 256 is the conversion from one to the other. And the nice thing about it is it's all fixed points. So if you go up to 32-bit or 64-bit, you know what your accuracy is in your measurement. And then you never have any bad values or values that are out of range. Like with floating point, you have to deal with NANDs and things like that. But that's impossible since everything is a valid number. And so any way you do the math in integer, and that's the other advantage, is it's really fast because it's integer math.
Right. Yep. Yeah. So if you chose 12 bits, you'd have, you know, 4,096 divisions around the circle, and 16 bits, whatever it is, 65,535, I think. Divisions, you know, around basically.
Yeah. And it's easy to convert it back and forth because it's just, you know, taking 2 to the number of bits and dividing, multiplying by that.
Mm-hmm. Yep. Yeah, so it's pretty simple. Anyway, so I hadn't investigated it before and thought I should. So.
Okay, very cool. Well, thank you, Ray.
Yeah.
Sounds good. All right, so we have next in queue, we have Scott, then Ian, then Pat. So Scott, what have you got tonight? Good to see you.
Yeah. Thanks. Good to see you guys. Just a comment for Ray. I mean, all that seems kind of computationally excessive. You know, dividing it up into those bits, and there's a lot of if statements. And while you were talking about that, I brought up Burp's code, and basically what I do there is I take and I convert because there's headings and then there's degrees. So your heading would be 0 to 180, and then negative 180 represents the left side, so you can understand directions of where your target is. And basically, I just take the fractional part of it and then scale it to whatever I want to, whether it's 360 or 180. And I actually add it so it comes out, whether it's negative or a positive angle, it always comes out in the right direction.
Yeah.
And actually, I think a lot of that's based on the old code that David posted. That was years ago, and I was actually looking for that odometry algorithms and equations that he had posted a while back, and I couldn't find them the other day, but it was very helpful and I think very clear in how those conversions work, because there's looking at your code with the bit weightings, you really would have to wrap your head around that to say this is how it's working, right? I mean, I'm not sure how long you spent getting it to work, but so anyway, that's just my comment on it.
Yeah, you don't need to do all the bit weighting though. You can just divide and multiply to do the conversion, because it's just a simple unit conversion.
Mm-hmm.
Yeah. Well, I mean, I can show this code too. I mean, I basically, I wanted to just show, I've been working on Burp, and I got tired of people calling it a tractor that went backwards. So I've got some pictures. I've been converting the chassis to 4-wheel drive and looking at different sensors. I just got one of these Cybot D1 time of flight cameras, and I can show the little their little demo app. Very interesting technology. I'm really starting to kick around some ideas of how I'm going to, the algorithms to use all this data, because you're looking at the packet to include the entire window is almost 10,000 bytes. So it's quite a bit of data, and I've dealt with that on CanMan, with 360 degrees of data. And that was challenging enough to sift through. And so this is going to be a real interesting process, I think. But I can, here, let me.
Yeah, let's pull it up.
So anyway, can everybody see that?
Yeah.
Looks like a tractor going backwards.
So everybody's familiar with what Burp looks like, right? I mean, I've got sonar sensors in the front, which I'm going to replace with this LiDAR camera. So I just took some last photos because no one's ever going to see this again.
Well, yeah, isn't that a tractor that goes backwards?
Yeah, thanks, Harold.
Yeah,
So, and I actually weighed it, and one of my objectives is to try to, even though I'm going to have more wheels, try to reduce the weight. So this is basically my idea is we have a box, and then the 2 wheels on either side are going to be linked together by a chain. It's the same set of motors that was in Burp, but this time, instead of having a gear reduction even outside the planetary gears, it's going to drive the wheel directly, as you can see right there. And this is another shot of just the spindle of the wheel and the way the motors are going to be set up. Here's a better picture of it with the wheels on. It's a really gnarly looking chassis. I've got some pictures of it sitting out in the grass here in a little bit. But you get the idea of the chain drive. And basically you just have an idler pulley down here. And this is all hardware I got from, what is it? RC, or the Servo City. So this is all their hex shafts and bearings and chains. Really nice hardware. Even the hubs I used to mount to the wheels, which unfortunately, I guess I didn't get a picture of that. Really nice stuff that they've machined. And here's another picture of the drive assembly. And here's what the chassis looks like. And once I'm finished with it, it's going to have, covers on it. And I got some better pictures here, some additional work. So I don't think it's going to be falling over anymore. And certainly no one's going to call it a tractor. Maybe a Bobcat, but not a tractor.
Well, I don't know. They have tractors that have, 4-wheel drive and
Yeah.
tires.
Well, so is it the wheels that everybody thinks it's a tractor, or is it just the spindles?
We
But,
just like to give you a hard time, Scott.
Yeah, is that what it is?
Yeah, so we give you a hard time but I will tell you, I think it's the combination of the wheels and the spindle
Yeah.
it's not any one thing, it's a combination of the thing.
But Scott,
Yeah, well,
I love those wheels, those big wheels you got up front. I think those are like, dude, where can I get me some of those?
Yeah,
So,
it kind of looks like something you would enter in a miniature monster truck rally.
Yeah.
and it looked cool as a tractor. I mean, I know some guys who collected antique tractors. So I mean,
Yeah.
I would take that as a badge of pride.
Yeah, Scott, I would simply own the idea of tractor. Just own it and be proud of
Just
it.
go with it, huh?
Yeah, yeah.
Well, if it wasn't so top heavy and unstable, then I probably would have been able to deal with it on a personal level. But after, it tumbled down the hill in the contest there in August, and it actually damaged one of the sonars. So I basically ruined 2 run attempts before I figured out the sonar was messed up. So, and that's the objectives here is I'm going to, lower the center of gravity, make it more stable, give it more traction with the 4-wheel drive, and provide a better sensor array, because I was never really happy with the sonars. I always had trouble with them, especially when it's windy. And, so I think this LiDAR technology is a much better technology. But right now, this is another shot of basically the chassis without the wheels on it. And my goal right now is just to convert everything over to the burp hardware. But I also want to start doing object recognition and some OpenCV work. So I'm actually going to be, right now I'm looking at putting a Jetson Nano in here to do the OpenCV. But just to verify the chassis and the hardware I'm building, I'm going to just convert it over to burp, all the burps hardware. It'll end up using the burp, the motor drives, the H bridges. Those boards will stay even if I change out the CPU. So that's kind of where it's at. And so hopefully it'll be more consistent next time we roll it out. So I have a little video. I just hooked it up to my battery. You can see my drill motor battery there. Just a little video of the wheels running. I was surprised at how quiet it was with the chains. I was worried it might be a little noisy, but and since now I'm driving the wheel directly, it's going to be about 30% faster too. So it's going to be a handful to keep up with, I think.
Is the hardware like, number 25, number 35 chain, or is it metric chain, or?
That's a good question. I don't remember. It's like the smallest chain they sell. Of course, everything they do is millimeters, but I used the 8mm hex shaft so that I didn't have any slippage of the gears. And these are just, the gears that fit on there and collars to keep. And then I also got their, 8mm hex bearings with the flanges on them. I was able to find a 14mm hone. So I was able to machine these holes accurately for the bearings. So it's been a lot of work. There's a lot of man hours in here because there's a lot of machining, and but I think it's coming together quite well. I'm happy with and right now it looks like it will be either about the same weight or maybe a little lighter, even though I'm adding the additional wheels. because I'm one of the car terms I hear a lot is adding lightness. So every time I add a part or machine something, I was like, can this be thinner? Can this be lighter? Can this be done, in a better way? So I think the real work's going to be, this new sensor technology, which is, you can see this right here, and you can see me, it's just sitting here on my desk. But each one of these different colors here is a different range. Like you can see, and each one of these pixels is actually a reading that's coming out of the camera. And so, look, now it stopped.
What did that thing cost you?
That was $170 from.
Not bad.
Yeah, it's not bad. I think I got that from SparkFun. Actually, is where that came from. I don't know
What's it called?
Do what?
What's it called?
It's the Cybot. It's a D1, they call it.
Okay.
And right now, it just basically it's hooked up via USB. Come on. I'm not sure why it's not working now. This thing was working great before y'all saw it.
Demo effect. I think.
Demo
Yeah.
effect.
But like I said, it's going to be a challenge to try to, figure out how to use all that data.
There you go.
And my idea, and that's one thing I wanted to open up for discussion, maybe some ideas, because I want to use it both for object avoidance and, possibly object recognition. A cone has this particular shape, right? So, and my idea right now is to basically try to generalize some of this into hotspots for object recognition or object avoidance is the first goal. So because this thing is, it's 160 bits wide and I think it's 65 bits long. And I've never seen it crash like that. But so my idea is that I'm going to generate hotspots and try to generalize some of this data. If I can get it going again here. And again, I'm interested in people's ideas of how it might, if that's a good idea, what would be your other suggestions? Certainly you can't sit there and scan through every sample, and make a decision based on an individual pixel. I think that'd be too intensive, but so anyway, and here's just to finish up with what Ray was showing. This is the code from Burp right here, and this is what converts the angle. You can see the comments here, plus and minus 180 to 0 to 360, because you're always doing that, and then you have to go the other way where you go 0 to 360 into plus and minus 180. And after looking at Ray's code, and I look at these, 6, 8, 10 lines of code, I'm thinking, I think I'd rather debug this than Ray's code personally. But so anyway, it's just a different way of looking at it. And basically, all I do is create a fractional value, and then say, okay, well, my overall number is 360. So what fraction is it that I actually have? And then I just do a short test to see if it's 180. You flip it around. Basically, you just rotate all the way around to make it positive or negative.
Well,
So
the other function that I did was just 3 lines there. The one that wasn't banned, that gave an integer output. So
yeah, I think it was similar to this one here, where you're taking the 360 and you're getting a plus and minus 180. Now, I think the beauty of what you had, Ray, was that you came out with a difference. You could pass it different coordinates, and that, for my code, that's done differently. That's done over here in this function called locate target, where I'm trying to calculate the distance, And again, this is all based on what David published years ago. I've made some modifications to it, but so basically my heading, to figure out where I need to go, because in my world here, this target dot heading is where do I need, how far away to the left or right is the heading. So that's that difference that you were printing out, Ray.
Right.
So it's just done in a few different spots. And then of course down here, that's this clip heading. So now I'm putting it in a plus and minus 180.
Right.
So because anytime we're doing, the trig on this, trying to calculate where it's at, you basically need radians, right? So then you have to convert your plus and minus 180 back to 0 to 360 in radians. And so, yeah, you're always converting them back and forth. I don't know of any way around that.
That's
I don't know, like I said, it's all David's code anyway. Is there a better way, David?
Well, yeah. do your sine and cosine functions in BAMs.
Oh, okay.
Hey, I was looking at that.
So you're just adding angles.
I was looking at that product description for the Spark from LiDAR, and they say that the 2D detection range is 8 meters and 3D detection range is 2 meters. What do they mean by 2D detection range and 3D detection range?
You can put it in different modes. Let me see if I can get it to come back up. Because you can tell it, and that's what this selection is here. Like if I go to 2D mode, or here, I'll tell you what, I'll just go to both, because you can also set it in a mode where it does both. And basically this is your 2D pixel. So it only takes and I'm not sure exactly where in the frame that it actually takes the 2D data from, probably like right down the middle here. So that's what they're talking 2D.
I don't understand at all.
Well, because
looking top down, maybe.
The 3D is like I described earlier, it's 160 degree field of vision, and there's a pixel for every degree. So there's 160 pixels across every line of this, and there's 65 lines coming down, just kind of like on a TV, right? So you have the 160 by 65, and whatever the math on that is. And I don't know why it keeps crashing, but
and depth for each pixel.
No, I'm not sure why it affects the range, because it's the same sensor, right? Or unless they're consolidating, like I was saying before, trying to consolidate the information into a single line instead of a frame, right? That's the difference. That's what they're talking about, 2D versus 3D. And the thing that, and unfortunately, it keeps crashing, but one thing that I have found is, like, if you're right in front of it, it'll blind quite a larger field, because it seems to disperse quite a bit. Even though, because you figure you have a 65 degree field of view here and 160 degree horizontal field of view, so it's going to disperse quite quickly. But if you block it fairly close in, you have a very large blind spot behind there. But like I said, it's going to be, I think being able to utilize the data is going to be the biggest challenge with this thing. The serial packet structure looks fairly straightforward. Or I think there's a ROS interface for it too, according to the documentation. But so, like I said, if anybody's got any suggestions of how to use this data, I'd be happy to entertain them.
Scott, I don't know if this is the specific question you were asking about wrapping the heading pointers at 360 or 180.
Yeah.
But I talked about this a little last week, and I couldn't remember if you were here.
No, I wasn't.
Okay. Basically, what I'm doing on my robots now is that I have two heading variables that I call theta, and one of them is called total theta. and I don't wrap it. I just let it wind up, and I do all the math off that one. And then when I'm done, so, 1,413 degrees plus or minus 45. Then when I'm done, I can clip that to either plus or minus 360 or plus or minus 180. And it's just a single instruction. Basically, you take the number you've come up with and subtract off, let's call that value theta. You say, I'm going to subtract off the integer value of theta divided by pi, if you want 180, times pi. So basically, you're subtracting off everything greater than plus or minus 180. Or if you want to do it 2 pi, that's plus or minus 360. So
But
that's
if you're using pi, you're dealing with radians, right?
yes. I keep everything in radians.
Okay. I tend to, well, my compass gives me degrees. So that's basically what I'm doing here, right? With the 180, or actually rotating it all the way around, and or finding the fractional part. And this is an approach I use quite a bit anytime I'm scaling one number to a different, number base, if you will. Even things like, my PWM value to whatever my PWM hardware will take, whether it's 12 bits or 16 bits or whatever.
That's sort of like, that's the same function I use. That's sort of like a floating point version of a modulo function.
Yeah. So that's all I have.
I do the same thing, but when I read back the heading in degrees from the IMU, I convert that, as I read it, I convert that to radians.
Oh, okay.
Because all your math is going to have to be in radians.
Yeah, well, I mean, that's what I do over here is convert it. I have this constant value where I can just, I have a degrees to radians value as well. But yeah, I mean, you're still doing the math operation on it. So I guess to me, logically, thinking about it, it's easier for me to keep up with angles than it is radians.
Scott, can you put the a link for that sensor or the name of the sensor in the chat?
Sure.
And Scott, you also keep on mentioning BERP. I don't know what is the term. Is that an open source software for the robotic system? Yeah,
the viewer that keeps crashing. Yeah, you can download it from the Cybot, I think is the company that makes that.
So BERP is the software which Cybot provides.
BURP, BERP. BERP is the name of his robot.
Oh.
And is that an open source robot or a particular name for Scott's robot?
No. That's all handwritten code there. That's all straight out of this computer.
That's his robot's actual name.
Okay. Yeah. Sorry about it.
It's Big Ugly Robot Project, but I'm trying to, instead of calling it BERP 2, I'm thinking about just calling it Belch because, Belch is like a full-blown burp, right? But I can't come up with the acronym for it yet. So
Can we have a name Scott's Robot Contest?
Do what?
Can we have a name Scott's Robot Contest? We can come up with names for you.
I'll take suggestions. As long as it has to do with some body function.
You can call it BERT. It's a Big Ugly Robot Tractor.
Belch. Yeah. Burp even larger, CH something.
How about freewheeling autonomous robot technology?
Part. That's a good one. I'll have to, let me write that down.
Nailed it. Freewheeling autonomous robot.
You got to trademark that?
Scott, the only thing I could say, and I don't think it'd be anything new to anybody in this group, but the one thing that I've noted is that as I've been playing around with this Mars rover, the big difference between it and my current robot is my current robot's this far off the ground and the Mars rover is that far off the ground. And one of the things I noted is that if you're doing obstacle avoidance and you've got your sensors that far off the ground and your obstacles are low on the ground, you're basically looking over top of them. So it's one of those things where you kind of need to either have sensors that can see downwards, but if you're, if they're 6 inches off the ground looking forwards, they're not going to see things coming underneath them. So that was the only thing but your robot looks to be relatively low to the ground.
Yeah, it's not going to be very far off the ground, and this is going to be mounted within the body, so it's not going to be on top of the body. And actually, if unfortunately this thing won't work right, but I actually plan to use the range of the window in my favor, because one of the things, like in my backyard, I have a short retaining wall, and in the course I have in my backyard, I kind of have to go around the retaining wall so I don't like drive off of it. So one of the ideas that I had was to actually mount the sensor to where the bottom few lines, you should know that it's the ground. In other words, you should always see a reflection that's within this range, because the ground's always going to be there. So if you're driving up to a cliff or the edge of a retaining wall, then hey, I need to stop and back up. So yeah, I was going to use that, and I think that's going to also limit the amount of data I have to process for obstacle avoidance, because I can cut off a whole strip on the bottom and say, this has got to be less than X distance, or I'm fixing to drive off of something.
Right. I think I was mostly reacting to your backwards tractor, because I think your sensors on that one are really quite a ways off the ground, weren't they?
Yeah, and that's one thing that made it so top heavy and unstable. And the idea here is that I'll probably have a camera gimbal and camera array mounted on top of the chassis. But I don't think it'll be quite as high as Burp's was. And it'll be bi-directional, so it'll rotate, and it'll be a full camera gimbal, so that you can do more of a search with the camera and look around, if you will, with it.
Scott, one problem I ran into, and you probably have seen this before, when I was working on it, basically I didn't want to fall down the steps. So they're doing the same thing, trying to bounce a signal off the ground, and then in its absence, don't go that way. But I found there were other reasons that could cause its absence besides an edge. So certain color patterns and so forth, it wouldn't cross, it wouldn't go over, because it thought it was an edge. So for what that's worth.
Yeah. Well, I'm sure there'll be pitfalls, but I'm trying to use all my knowledge and experience and the reasons why I've lost contests in the past to try to avoid that in the future.
We're looking forward to FART. That'll be good. All right. So
hey, Kareem, you were working on it was one of the what is it, Intel Sense cameras, the RealSense, that's maybe not what it's called, RealSense. Anyway, have you made any progress? Because you were trying to separate out like basically the floor from obstacles on the floor that appeared as the same shading for depth. Did you? And that sounds like what Scott's kind of looking at now. Have you made any progress on that, or?
I haven't worked on that in the last 2 weeks. I did show it 2 weeks ago, that I got it at least to the point where I could isolate objects by comparing them to a ground reference plane, and basically subtracting the ground reference plane out. And so I am able to identify objects, and I can tune the pipeline to sort of create a minimum height off the ground where I would start worrying about them. But I didn't get to the next level yet. I haven't had a chance to look at it to sort of start intelligently being absolutely sure where those objects are, because there can be strange situations where you have now I'm talking about complex environments where you have a lot of overlapping objects from the point of view of the camera, right? So you might have things that's partially obscure other things, And though with this simple approach, they all sort of merge together into larger blobs. And so you have to take the precaution of finding the nearest pixel in any particular blob to consider whether or not that's an obstacle you need to worry about. And then you also need to compare it where in the frame it is to like the width of your robot through the vanishing perspective point to see if it's something you might hit in the current direction you're facing. So I haven't gotten to those extended cleanup functions of filtering out just the ones that matter most and route planning around them because I've been focused on helping my robotics team start up their season.
Those pesky students.
Yeah, but it's a promising approach. It's still probably not the best way to do it. Probably, so I'm taking that first because it's the simplest, sort of the simplest way to do it. And so the blobs themselves, right? So think of them as just outlines of potential objects. That can still be used to go back and look at the original depth data. And you can just scan through the outlines that's created, the contours created by those blobs to find the the nearest pixel. And then you can associate it with that with the entire blob. And then based on its spatial location, you can decide whether you need to avoid it. So it's certainly a possible technique. I haven't extended it into, right now I'm basically comparing it in in an unsigned way, and I need to change it to the resulting frame still has a sign bit on it so that I can also discover holes in the ground and things like stairwells that are descending, that kind of thing.
Yes.
And so the same algorithm can still find those as well. You don't see that as often with indoor robots, but I think outdoors, if I need to detect a ditch or something like that, it's going to be important. But ultimately, my guess is I might actually be looking at converting it. I also have access to the point clouds, and I'm thinking that maybe I'm going to have to do more of like a geometric ground plane identification and removal based on something like a ransack, or there's lots of other algorithms for sorting out point clouds and classifying pixels in them, and so that ultimately might be the way that we go. I'm not sure.
Kareem, as you were
The other
talking,
question I had is you referenced degrees to BAM. Is that some unknown C function that was built in that I never came across or something?
No. That was an accident. I mean, I haven't quite finished that, but just listening to the conversation, I didn't mean to actually. I was just writing and hit enter too soon, so I hadn't finished working it out. But I think that's the formula for like the least significant bit. But there are simpler. I'm sure from what the others have said that there's a simple way to convert degrees to BAM or and back. Yeah. Without
Kareem,
going through a bunch of if statements. Yeah.
Kareem, when you were talking about point cloud,
Uh-huh.
one of the libraries which is used by quite a lot of people is called CoalMap. And you can use CoalMap to measure distances between different points. Is there a particular library you are using?
No, I haven't really ventured into the point cloud stuff yet. You can get the native API or SDK for Intel RealSense offers a way to get point cloud representation. I think most of those folks are using the point cloud library instead, but we haven't gotten to the point of actually using it.
If at all you get into it, the Intel RealSense not only provides you images but provides the point clouds. Because one of the things which we have been working on is, let's say you have a point cloud, and obviously point cloud is a three-dimensional representation. You take point 1 and point 2 and you want to measure distance. One of the well-known libraries, one is Open3D and the second one is CoalMap. But I guess you're using whatever is provided underneath the RealSense API, and you're not going into the details of the library itself, is what I heard.
I wouldn't say it that way. I'm just saying that we hadn't chosen a point cloud library for analysis yet.
Okay.
There is a point cloud representation that out of the box, the SDK, you can call a function to convert to a point cloud representation, and that is, I think it's compatible with point cloud library. And the trick isn't getting the distances between individual points. That's pretty straightforward. The trick is to classify all of the points, like all of the points that belong to a ground plane, so that you can sort of ignore them, right? And so, what are the techniques for that? And that's probably not 100% simple and straightforward. Some of them might be sort of imagining, sheets and modeling the tensions between points and things like that. So it's probably not trivial analysis to do that. I've seen some examples of classifying purely flat planes like a tabletop or something like that. But if you're interested in finding all of the points that belong on an undulating ground plane outdoors on a street with potholes, and identifying only the potholes that are too deep for your robot, it becomes a little bit more
So Kareem,
complex.
So one other tool which is available is called LAS tools, LASTOOLS, and primarily it is used for LiDAR, not from robots and real sense, but planes flying about the ground and taking the overall location of the city or map. And
Right.
LAS tools has a function wherein you can specify, get me all the planes on the ground plane. So it will color all of them in brown and return only those values. I have not seen it applied in the case of robots with real sense, but more for airborne collection of LiDAR to get the city and the roofs and all that place. And in that
Sure.
LAS tools library, there is a function which says, get me ground plane points, and it will take the point cloud and color all of them as brown, and then higher things it will show green, so it says vegetation. So identifying elements of in a plane in point cloud is a methodology available in multiple libraries. And
Yes,
if you are
yes.
exploring in detail, I can point you to some specific functions.
Yeah, I'm not aware of that particular one, but there are like a lot of those. And the things that are developed for drones have the benefit of having much bigger differentiation between depths, and a little bit more uniformity with that downward looking view. And I've got a very low angle of view on my robot, and the way the camera has to be set up in order to look forward at the same time as detecting things nearby on the ground. So the geometry is quite a bit different as well. So I don't, well, I'll experiment with a number of different options probably before I settle on something. But
Kareem,
yeah.
Can I just throw a dumb question out? Because as this discussion has been going on, I've been thinking about and wondering. So, because Kareem, when you mentioned your approach, it sounds like you're using the visual spectrum to kind of classify blobs and areas, and then you're going into, after that, examine the depth within that area. Is that right?
No, no.
No. Okay.
Well, sort of. All right. So what the RealSense depth frame gives you is a regular camera image that's been rectified so that all of the pixels correspond to what the left depth sensor sees, the left depth camera sees, and they've all been normalized so that you can multiply them by a single scaling value, that it'll give you your depth to that pixel in meters, right?
Yeah.
But it is constructed as a regular, not RGB, but a black and white frame.
Sure.
Effectively, right? And so you can use image processing techniques right out of the box. And so I have a stored reference value of the ground plane, which is nothing else in the room and just mostly seeing the ground to the depth that the camera is reliable to, right? And so that's the portion of the image that I'm interested in. And so I subtract from that the actual real-time depth frame with stuff in the scene, right? And then the difference between the two gives me effectively an image where only the differences are significant. You still have to threshold that to get it to like a black and white, and then you're using regular blob processing to find and dilation and erosion and things like that to process those into just, now you've got black and white blobs, and yeah, then you find the contours, and then you use those contours to go back to the original depth frame to sample the actual pixel distances and find like what's the closest pixel in that group, and you'll sort of assign that to the depth of that object, the outline of that object.
Okay,
But
so
it might actually be two objects if they're like right behind each other from the camera's perspective.
So if I'm hearing buried in there, the big question I had was that since, and you answered partly, I think, in that you said since the depth data itself looks like a black and white image, so you've got depth in an XY grid of pixels. So it's
right.
Basically, you can almost think of the depth as another color.
Sure. In fact, they by default they will colorize it because it's easier for humans to process it that way. But it's not a great way to do it until the human needs to see it.
But it strikes me that if you think of it that way, then you've got all these great algorithms that were starting off with visible spectrum pixel data, so that you could find like objects and flood fill and erode and edge detect and all these other things.
Mm-hmm.
It seems to me that those exact same algorithms could very easily be applied to the frame of depth data, so that without even looking at the visible light, you could just do blob detection of depth. You could take the blob, you could take the depth image, black and white depth image of where each pixel value is the depth, and then you could do a blob detection on the depth image, and then you could in that way do segmentation on the depth image and figure out those like areas which are closer and those like areas which are further.
That is what I'm doing.
Okay, that's my.
But yeah,
cool.
That maybe I didn't say it right, but that is what I'm doing. I am still taking an initial step of subtracting a reference image.
That's the
from
only,
it.
Yeah. Okay, that's the
right because otherwise everything is a smooth gradient in both images,
right.
And the differentiation isn't probably quite enough, and that's the most meaningful thing to do, because the floor is the thing I'm least interested in.
Okay, I don't know why it took me so long to click, but thank you.
Sure.
That's my question.
Hey Karim, did you see if algorithms that's using deep learning for segmentation, like image segmentation, is something that you can use? I haven't particularly looked for this, but just thinking that it's a 2D image with basically grayscale being the depth of the pixels or distance from the camera. I think it should be possible to do it. You might have to take a model and train it again with some data, but there are a lot of algorithms for object detection to segmentation models in deep learning. Just curious to see if that could help you, or is someone doing that already?
So we haven't. So when we tend to use deep learning models, it's more about specific object recognition, as opposed, because I don't care what the object is. This is not about identifying objects. It's about avoiding obstacles. Right. So all I care about is there's something in the way for this particular instance. That's not to say that there aren't cases where we would also be interested in it. So, for example, if we were doing it for RoboColumbus, once we get to the cone, absolutely, we'd probably want a cone detector that might be a TensorFlow model or something else, which is actually probably more overkill for this particular case, but we're wanting to always experiment with those kinds of things. I haven't run across great reference so far about general obstacle avoidance through deep learning approach. Except in more, the more complicated cases when you're talking about things like, multiple sensors on moving cars and big budgets and things like that. We're looking for something simple.
Yeah, I think it's possible, but again, yeah, if there's a simpler solution, definitely take that over this. But I think this can also solve some of the problems if it's getting more complicated.
Yeah, I mean, my goal is to simply be a little bit more, getting a little bit more resolution than say Dave's ultrasonics. Something like that. To just have a little bit more certainty, maybe able to navigate through small openings between between trees very accurately and that kind of thing.
Cool.
Very nice. Well, Scott, you kicked off quite a discussion there. Thank you. That's who'd have thought that we'd head down a path like that. That's great. Okay, next in queue we had Ian and then Pat, and then I had a kind of a club question discussion. So think about who wants to go after that. So next up, I think then that means Ian.
Yeah, can y'all hear me all right?
A little metallic. It's like you got a wobbly microphone connection or something.
Well, I'm actually using the built-in mic on my laptop.
It's just overdriven. Back off on the volume.
Way overdriven.
All right, cool. Just a second. Okay, how's that?
Much better.
Okay. I don't talk much, so I didn't know how to have that set.
It's still a little overdriven, but it's
okay. Let me
understandable.
Quick. I can do that. Input devices.
That's better.
That's perfect.
I hadn't even done anything yet.
It changed. We heard the change. The volume. The back. There's a hum.
Okay.
We heard in the background.
Sing.
Sing? Oh yeah, right.
Yeah, it's still a little driven. It's all right. We can understand you.
Okay. One more time here then. Okay. How's that?
Good.
Okay. Good. So I got two things. One, I was inspired by Carl with his old RC car robot, and so I had to dig out my old RS4, and I've literally done nothing but mount the Arduino to it so far. Haven't even wired it up. But looking at it while y'all were talking, I realized that I used that I've got a forward-only speed control on it. So I'm going to have to change that out because I'm going to need some kind of reversing action. But what brought me to this was I got, when I showed y'all that battery pack a couple months ago, I think that I made, I got these little 12 volt to USB adapters to power an Arduino or a Raspberry Pi. And I was like, well, you know what? I can use the exact same thing to power an Arduino from a battery pack on the RC car. So I'm going to use that to power the Arduino, and that's about it for this. But then that brings me to something that I've actually completed, and based on that same, let's see, can't really see it here. Right here is that little 12 volt to USB adapter I was talking about. And then I realized that I needed to back up my server, and I've recently become Raspberry Pi rich. So I was like, that's a perfect thing to power Raspberry Pi. And I built this, which is kind of shiny. You can see the Pi in there, and it's just mounted to a big old hard drive. I've got 12 volts coming in to power the 3.5-inch hard drive, and going to the USB adapter to power the Raspberry Pi, and made myself a very small, low power backup server.
You know, there's no such thing as too many Raspberry Pis, right?
I didn't say I had too many. I just said that I was Raspberry Pi rich now. we had a project at work that we had scrapped out finally, and I think I had I don't know, maybe about a dozen Raspberry Pis that we were just getting rid of. So so I got some, and another guy at work took a few of them. And so anyway, that's basically all that I had. I was just all proud of this. My backup server. I actually finished something.
And it works.
And it works.
So we should call that a gold star. That's the
Yeah.
first working, right? That's
Took me just about most of the day to back up my server, but it works. Works great.
nicely done.
So that's all I had. I actually accomplished something, so I wanted to share.
That's cool. Progress on two things, right? You're moving ahead.
Righto.
Yeah. All
So
right.
with that RC car, I think I've got some ultrasonic sensors that I've just got to build a mount to put them on the front to start trying to do some obstacle avoidance stuff. With the motor that I've got in that thing and how fast it is, I'm kind of curious to see exactly how fast I can make it go and avoid obstacles.
So is this an exploration, or is this the gauntlet's thrown down for Robo Columbus next year?
I might be able to get it to move by then under its own commands, but I'm kind of slow sometimes.
With you on that.
But yeah, I thought about that too with the Robo Columbus to see exactly how fast I could get it to go, but then I have to figure out how to actually like identify a cone. But maybe, never know.
Who did we have in the club who was racing cars around and knocking barrels out of the way?
Jesse Brockman, who's not on tonight.
Yeah, he might be someone to tag for a little bit of advice, because he definitely he's got the high speed RC car thing down.
Okay.
Yeah, I don't know if you saw what he was doing, but he was racing an RC car around at high speed with, was it autonomous or semi-autonomous, or is he just controlling it? I can't remember.
Yeah, it was fully autonomous. It was just a big vehicle.
Or you could take Ron's advice and never build a robot you can't run any faster than.
Right. All right.
All fun. Well, cool. Well, we look forward to following your progress, Ian, and helping if you get stuck and clapping for the next time something
get stuck
moves.
on code, but we'll see what happens with it.
Right.
I may, if history has taught me anything, I'll probably change my mind about a half dozen times before I actually like get something going.
That's part of the requirement, I think.
Right.
Cool.
Coolio.
All righty.
That's all I've got.
So we swing around to Ontario. So Pat, what's going on in the Great North? Is it starting to get cool and white up there?
Oh, it was a beautiful day today. It was 21 degrees Celsius. So that's 72 degrees.
Yes, this is wonderful.
Yeah. It was nice. Actually, I've been working on yard work since I came back from New Brunswick. So I was siding a shed today. But also, I was catching up on old videos that I missed while I was away working. And so far, I was in the August 24th meeting, Robot Builders Night Virtual. Remember that way back, August 24th? I think it was right after the contest. And Doug Parody had mentioned me specifically in the meeting, and was talking about moving Robo Columbus to November. I would have to build a robot with snowshoes for November. Anytime after Halloween, the end of October, we could get snow up here. And usually it's just a small amount, but it'll stay sometimes it melts.
I would like to see the robot walking with snowshoes.
I would need a lot of help to build that one. So it's just my input on that. If you guys are looking to do a contest in the fall for like a Robo Columbus, Second to third week of October would be about the latest up here where I can rely on no snow.
Well, I think that's a good time. By the just
See you in 2 weeks.
Yeah.
You're on.
I wasn't throwing down the gauntlet. Yeah, 2 weeks is a little quick. I haven't had a chance to revise any of my code since August, but I will for next year.
Yeah.
And the other one I wanted to just show off, I guess, is I've revised a 20-year-old. I'm looking to revive a 20-year-old robot. So back in the 2000s, I had built, and I don't know if everybody can see this. It's a little 2-servo walker. Basically, just mounted on a frame. It was powered by Motorola 68 HC11, and it had a sharp infrared distance sensor on the front for obstacle detection, just to back away from an obstacle. But it was all written in assembler, and it could go forward, left, right, back up, left or right. So it was not bad for 2 little model airplane servos.
You had an actual distance sensor. When was it built? You said
in 2000, using
okay,
a sharp,
all right.
using a sharp infrared distance sensor. It was a digital sensor. It put out a signal, and I forget, it was a binary signal that it would put out.
Oh, that's what I was asking, because I remember back in those days, we were using the thing that the remote control IR signal receiver that wanted to receive 40 kilohertz modulated IR, and it was putting out, just a digital signal. So that's not what you were using. It was actually a distance.
It was a sharp distance sensor.
Okay.
So it was one of their first.
So it's not that retro. I was thinking maybe what you had was even more retro.
No, I did make a sensor using the infrared remote control receiver, basically to subtract out the 40 kilohertz signal and get a digital reflection back on it. But I didn't have that much work on luck with it. David is showing the sharp sensors, I think.
No, that's what.
Oh, that's the infrared remote signal.
Yeah, that's the old in the metal can. They're the ones in the metal can are the old ones.
See, there's 2 of them there, and then some IR LEDs in the middle.
Yep.
There you go.
So I did have a few of those on a different robot, and it's long gone. I don't know where it went now.
Well, this is not actually retro. It's just a really old robot.
So it's nice to be known as retro, I guess, even if you don't realize it.
Yep. So I'm thinking about putting a processor on that. I'm thinking of using actually my camera, my OpenMV4, and using that with some, I don't know, horizontal line detection. They're trying to find the edge of a tabletop or something with it, keep it from falling off.
Just put some snowshoes on the feet.
Exactly. That's
cool.
it for me.
That's pretty cool. All right. Well, thank you.
Oh,
Okay,
hey,
well-
Pat, this is Glenn. I have an insect bot, Arduino robot here in the my shelf behind me that probably would run. It uses an HSR ultrasonic sensor. I can show it to you, but it's probably run on your robot if you put an HRS sensor on it. If you want me to grab it, I'll show it to you.
No, that's what I'm thinking of putting on it, but I'm looking as well for a video.
Yeah, this was just a simple. It actually looks. It has two standard small servos. I taught a robotics class to kids, and it was a simple demo robot. But you can see it has the simple tower, the little tiny tower, 2 of the simple tiny tower servos on it. And yours look bigger, but it has the same type of walking motion with the wires. And so I'll bet the code would run on yours, and it's just a simple Arduino with the HSR ultrasonic sensor. So it works. I've had it sitting here for the last couple of years. I've taught the class on it a few years ago, and I can have the code handy if you want me to send it to you.
Yeah, that one I've seen the code on that. I'm trying to do something a little more that I can let it roam around on a tabletop without falling off.
Yeah, this will fall off. I've always had trouble when
Yeah.
I demoed it to the students. It would I'd have to watch it doesn't roll off the table. So yeah, definitely a big problem. But yeah, you can if you raise it up. If does its tail sit up in the air? Because the next problem really is your sensor would have to angle in front of the front wires, in order to before the feet get to the end of the table.
Yeah, so my feet are angled, as you can see.
Okay.
So
Yeah.
when they turn, they do go a little bit forward, but I could have the camera looking down at about a 45-degree angle just to spot the tabletop.
Yeah, that would do it. Use those little cheap IR sensors would do it.
Yeah, but that's the other one, is just to pick up a couple little sharp IR sensors or time of flight sensors or something on it.
Yeah, Spark Fun has a new time of flight sensor you might use with their the Spark thing. It has a quick connector on it. You can just slap it on the top of that.
Okay, something to think about.
That's all I had.
Thanks.
Okay, cool. All right. Well, next I'm going to go and ask a question, kind of a quick club discussion question. But after that, who can we queue up to come after the club question? Okay, Doug P has something. Anyone after Doug P and John?
Doug P did not hold up his hand.
I heard Doug P is in parody. Okay, so
okay.
We'll go Doug P and then John G and then John K. So Doug P, John.
And Raj.
Oh, good. And Raj. Okay. All right. So in the interest of time, let me fly forward. My goodness, we still have 22 people online. It's remarkable. So, so we have the unfortunate challenge that for those that weren't here at the very start, I have not got speakers lined up concretely for the next few dates. I have one guy who I think could make November, or most certainly I think by December, but we're short on presenter for the club meeting this coming Saturday and then the following Thursday. So I was just going to ask, does anybody on the call here now have something that they would be willing to jump on board for this Saturday and present?
I can volunteer Paul. Paul sent me a note last week, and he said, do you think the group would be interested if I just put together some of the robotic stuff? You know, he worked for the U.S. military and then for a private company for a while. And I said, absolutely,
Excellent.
that we would be interested. So if you have his email, drop him a note and tell him that he needs to give us a presentation on Saturday. I
will absolutely reach out to him very soon.
Drop and give us 60.
Yeah. So barring that, I wanted to throw this idea out, and whether it's this coming Saturday, if need be, or another time. So I was thinking, just what about just having we go around the table and talk about what we're working on, but what happens if we just have a kind of a brainstorming the next build session? So, for example, if we were to throw this out with a few days notice and ask ourselves, what do I want to build? What do I want to build this spring or this winter, next spring, or forget that. I don't have the time and money to build anything, but if I had no time and money constraints, what would I want to build? Maybe I have some personal wish lists, some crazy target, some cool concept, some walking robot I want to try, some kind of new sensor or something. And I was thinking that if we put this out, maybe it'd just be interesting it could be like this, where we have a go around the table session. People could pull up, web pages or whatever, just sketch their ideas out and just kind of see if, maybe somebody's come across something new that they want to do, and maybe somebody else in the club is interested in it too. So what do y'all think? If we fell into a session like this, would this be interesting enough to do on a Saturday session? Because without something like this, or Paul to bail us out, I'm kind of at a loss for this Saturday.
You might combine Paul with that concept.
Yeah.
The two together.
Yeah.
For next week.
Well, that's not a bad idea. So he wouldn't feel like he's got to put together some big presentation.
Totally dumb. Yeah.
I think that's a good idea.
So
at some point, I would like to have some help on figuring out text to speech that does not require internet connection to some web service. I've seen some examples. I just hadn't got to trying them yet. But that's not to interfere with what you're talking about. But if people had ideas, I'd be excited.
Okay.
Have you ever heard of Mycroft?
Mycroft, I think, has dropped aside. I glanced at it.
Mycroft is still around, and they do, I believe, for the wake word and the suggestion, I believe it's all done on board Mycroft itself.
Right.
So
I
it
need
doesn't go
something
out
that
the
does not
internet,
require
convert to
internet.
speech. It gets converted right in the application itself.
Cool. I'll take
And
another
it's
look at that.
all open source.
Excellent. I looked at something called Pico Voice, but I couldn't get it together. But I don't want to get off on this discussion and interfere with what Carl was doing. I didn't mean to interrupt.
No. That's okay.
That could be a good question.
One of my
throw
wish
out
lists.
Saturday too. Speaking of that, I think, yeah, that'd be a nice little discussion.
Yeah, I was just trying to think of what could we do on a Saturday that would be different from what we do on a Tuesday.
Yeah, in I don't know the right word, but to add on to that thought, if we announced ahead of time that the topic was such and such, that would get everybody a chance to do some research and be ready to chip in.
And that's what I was thinking, basically.
Yeah,
So
something on that lines could work too.
I think
So Saturday, let's research that because that is a good subject. Because I toyed with a thought before in some or another, and I don't know where I saw it, but they use like Microsoft Word where they can speak the text. I don't know if you can send it to something like that to spit it out. So you might, yeah, think of that angle.
okay. Well, thank you all for that quick feedback. And with that, let's move along. So many people online. So we have next in line Doug Parody, then John G, and then John K, and then Rosh. So Doug P, what's going on? Doug Parody? Uh-oh. Doug, did we lose him? Video, I see your finger. But
I'm here. I'm
okay.
here.
Got it.
Yeah, I wasn't here last week, and I've been busy all week with my 50th year anniversary with my wife, and I had people in town. It was really hectic. So what I'm going to talk about tonight is kind of a mishmash of things that I was able to find or do in short periods of time. And I wanted to share with you because I think there's some good stuff out there. Okay, so give me a second. I'm going to present. All right. Okay, the first thing I wanted to mention was that for a lot of people who have been looking for these things, they just came in stock at Micro Center, and they have more than 25. So if you're interested in trying to score a Pico at the $4 price range, now's the time. And they do have an 18-minute in-store pickup if you're here locally in Dallas. They probably could mail them too, Pat. So that was one little quick piece. Then the next thing I wanted to mention is Maxim has come out with a new part called the DS28E18. You can see it sells for about $1.39. And it is a specialized one-wire to either I2C or SPI bridge. All right. And we've talked about I2C and SPI quite a bit. And this chip looks like it might be an interesting game changer for some certain situations. They also, so here's a little bit about it. it can be used to extend the communications distance to like, I think it's 100 meters. That's really a long ways. I'm sure there's a speed hit, but I really haven't looked into it that much. It supports 11 kilobit kbits per second and 90 kbits per second. So I think that is, and here it is for 100K and 400K and 1 megahertz IC squared slaves and the 2.3 megahertz for the SPI slaves. So anyway, now down here you see there's an evaluation kit. This evaluation kit is only interested in to people who are using these in industry because it's $100 and it's not worth it. I mean, $1.39 part on $100 evaluation system. But what it is good for, if you look up this particular evaluation system, they have a reference design, and if you wanted to, you could roll your own board pretty quick. I have not found them yet in any modules, so that's another piece that I wanted to mention. I wanted to also mention a resource. This is a fantastic. Oh, by the way, there is also Spark Design Spark has also put out a Ask the Expert about this chip. So if you want to hear some details, let's see, where is he? If you're not aware of this, this is an incredible resource. The gentleman, I don't know how to say this, I'd say Mortaza, but that's probably Mortaza, but it's probably wrong. But this guy is a really good teacher. And the particular one that I'm on right now, this particular link is a 2-hour course. And essentially what it does is it covers communication between Python on a Windows machine and an Arduino. I'll give you an example here in a second. Let me pull this up. Okay. Nope, not that. So, okay, so here's an example of sort of stuff they're doing. So if you look in the thing, you can see I have a Uno and a pot, and I can turn the pot, I can get it. So what's going on here is I turn the pot, the value goes to the Windows machine, and then it's displayed on this particular thing. She's an OpenCV to do this, so but it's real simple. And he's a very good teacher. This one is, like I say, it's the first lecture in a course that actually costs money. However, if I can find it, okay, this is his website. So the one I just showed you is one of these two courses, which is a paid course. But he has these courses for free. He has 6 hours of advanced computer vision, OpenCV C++. He has that, machine learning basics, OpenCV, and using Python and OpenCV for drone. So all of these resources, and like I say, pretty impressive. And I'm actually doing, I guess, the sample lesson here, and I've been having a lot of fun with it. Let's see, got that. All right. Okay, on the lighter side, let's see if I can. This is what's going on UTD right now. Apparently, they're doing between building deliveries on UTD with these little travel robots. And it says here, I deliver to Comet Starship-Dallas.com. Comets is their like the Mustangs are to SMU, or the Cowboys are to Dallas, to UTD, it's the Comets. So anyway, thought that was interesting. You can see 3 of them here. So, and my daughter, who's a teacher there, a professor there, says they're all over the place. Now, let's see.
Some students like to just find one and sit on it.
I wouldn't be surprised.
My
Okay.
son goes there too. So.
Okay.
What does it deliver? Lunch?
Yeah, it's used by vendors to deliver food orders.
Okay. Now, I'm going to show this, and this is an example. I'm not saying this is a fantastic robot. Don't get me there, but I'm just going to do a few minutes of this, and I'm going to skip around. But this guy, this is showing you how to use one of those 3D pencils. Okay, and I always thought they were totally worthless, but after watching him do this and a few other of his videos, I realized they could have some use, and I did pick one up. I'm going to mute him. We don't need it, but watch how he does things. Oh, crap.
Gotta get YouTube Premium.
Yeah.
I know it's expensive, but the amount of YouTube we watch, you gotta have it.
Yeah. Well, trying to
just get a good ad blocker.
Well, that's what I'm using on my. The thing is, I'm on my Dallas Makerspace account, and that's why it's not. Yeah, on mine it's all blocked. But see how he uses this mat to generate shapes. Okay, and he's using it to weld pieces together. Here he's doubling up on something. You see, he's going to make. Okay, see how he made that. Now this is interesting. So here's how he makes a flat plate. All right. I'm just trying to show you this because I think the technique is really interesting. Okay. This mat, by the way, you can buy them for they're about $8. And so you can see look at this thing he's built. All of this with a 3D pencil.
And I assume you got it for around $30, if I remember right, currently.
Yeah. I'll stop this. Well, I want to go to let you see.
Yeah, I have the pen, but I never really use it per se.
Yeah, I know. Well, I never saw how you could do anything with it.
Well,
but now I
the
see.
technique, but not to that degree. So I'm like, yeah.
Maybe not the most repeatable process, but still.
It can be relatively,
But I mean,
he did do.
We use it for spot repairs and welding parts together sometimes.
Yeah,
but
this is the one that I've got, and I think it's a pretty good one. This one right here. There's the mat, and here's the pen. I'm using I guess it's a Scrib 3D. And it was $30. But anyway, I thought that was pretty cool. And
what's the length for the mat?
The mat is about 11 by 11.
And they probably come in different sizes, if I remember.
Yeah, they have all sorts of different mats. This one was pretty much like the mat that he had, which gives you a rectangular area, gives you 30 degrees, gives you 45 degrees, gives you 60 degrees parts that you can make. So it's pretty flexible, but there's lots of other available things that you can get. All right. Okay, let's see. Ding, ding, ding. Went through that.
I can't see what it's called. It's too blurry. Is it just a 3D pen mat?
Yes, 3D pen mat.
And the key word there, if you know, is a silicone mat.
Okay.
Yep.
So effectively any silicone mat will work, but this is geared especially for the 3D pen. So that's why I'm going, I hadn't really realized that they have specialized mats now out there for it.
Yeah. Here's one that might this one for $10 might even be better. So I mean,
Doug,
you have to go look.
Why do you need 4 finger protectors?
I don't know. I gave them to my wife.
Because that stuff is hot initially. I'm
Yeah.
thinking,
Yeah, I mean, I don't know. It's a good question. I did see them, and I said, I think they just throw that in to differentiate their product. All right.
Yeah, or I think the name might give it away, right? If it's protecting your fingers, this is hot plastic, so.
Yeah. Well, yeah, but I've never had any problem with that. So the other thing I wanted to show you is
Always a first time.
I'm starting to work with the OAK-D a little bit, and some of the conversations we had. So I wanted to show a couple of things that might touch on what people were talking about.
On what topic did you say, Doug?
This might, some of the conversation about depth cameras that was going on before, this might be some, here, these are some items that might. So what this is doing, this is a depth camera, okay? And you can see in the center here, it gets the X and Y coordinate and the distance. So the thing behind me is 2.4 meters behind me. And you can use your keys here, which I think they did it because of a gamer, but I tell you what, I find it hard. So here you can see I'm a lot closer. And if I move into it, you find there's this depth camera, if I move it towards me, can do about, when you get about half a meter or so, you're going to run into the front end of it, and then it'll start getting weird numbers again. So you have to do this. But here, so what they're using is a region of interest. And, you know, there could be, your program could scan the region of interest, or you could define a different interest, or you could also have it maybe zoom around the center of the closest object. So there's a few things that you could do that might be useful for some of the problems that people are trying to solve. And now here's another one that I thought was interesting.
Can you vary the size of the box?
You could, in this particular example, no, because here you can move it around, but you can't really change the size. But the feature here is another thing that might be useful to people. Okay, so you ask what's going on here. See all those little red dots? Watch what happens. Did you see? They're falling. Otherwise, if you're not moving, you don't get the little vectors. I don't know if you can, I don't know if this is coming up.
Yeah.
Yeah, we can see it.
Yeah. So this is an idea that may be of use. A good example, I mean, you know, if your robot's moving, everything is moving, okay? So it may not be as useful as it first appears, but you could maybe say, well, if they're moving faster than what your speed of your robot's going, maybe that's something that you have to worry about. So anyway, I thought that was another application that was cool. And it can do, you know, it can do all of the standard stuff, but
well, Doug, a question on that. Do you get access to the vector data? Like you can see how long the lines are?
well, since you're generating them, I would imagine that you have access to them.
Well, then if you have it on a moving robot, then you could effectively sample the, you know, you could collect it, you could get a sample of the dots with the vectors and use that to tell maybe what direction something is moving, or even which direction, you know, you get a whole bunch of them, of course, but you get some. It's sort of like the thing that Cream's doing with the floor.
Yeah.
If you could basically say, okay, we have a whole bunch of these dots all moving a certain direction, that indicates a certain kind of movement, and then a movement in another direction would indicate something different.
Yeah, that's a very good idea. So I'm going to do something here. It could definitely catch something that was going different from the way you were moving. For example, I'm going to tilt the camera and you'll see all those stationary dots move one direction, but I'm going to move my head in the other direction. Did you see that?
Yeah.
So you could possibly from that information. But the other point is that it has found these points in the image. So, and I'm not sure how it's selecting them because they appear to be on edges or something.
So is that their example of optical flow, or?
Well, it is. It looks like optical flow, but I'm not sure, Ray, without going into more depth, whether or not.
Yeah.
So
yeah,
anyway,
look at the boxes behind him. It's doing edges and corners.
yeah. So, you know, that's another feature that might be useful to people.
And what board is this?
Okay. You know, I've been telling everybody that they should get in on the OAK-D-Lite.
Oh.
This
yeah,
is,
I bought one too. Yeah.
Yeah. It should do all of this.
I think everybody knows.
Yeah. This happens to be a OAK-D, which was last year's model. Okay. So anyway, it's kind of fun to watch. There's a large number of you know, and it can do all of the. One of the differences between the OAK-D and the OAK-D-Lite is that there's actually an IMU in the OAK-D, not in the other one. But you know, you can do. I think this is, you know, the standard pretty much. I think this is kind of, yeah. See, I'm a person, and it just says person. And a chair behind me, you know. So this is just your typical neural network type. What is it called? My headset. Anyway, so it can do all of that too. Anyway, that was something I thought that people might find interesting. All right, and I think I've covered all the topics that I wanted to cover, so I'm going to stop sharing. And if there's any questions, I'll answer that.
Well, one thing that pops up is I know that John and I on the Personal Robotics channel were chatting about trying to come up with a collaborative project. And again, one of the problems is that we all have different requirements. And so one of my requirements is to be able to handle an 18 to 20 volt battery. And one of the other guys said, well, I only want to handle a 12 volt battery. So it's always these differing requirements. But one of the things that occurs to me, Doug, is that you've talked about this Maxim DS28E18 one-wire interface. And I was just wondering if we got together as a group and designed an Eagle CAD or some kind of a CAD design for a PC board, we could buy these things for $1.30 or whatever and manufacture them. Would there be much interest in one-wire interface? I mean, on a small robot, you wouldn't need it, but maybe on a larger robot, it might be valuable. I don't know. But it could be a collaborative project that we might, if there's enough interest, like if 3 or 4 or 5 people wanted one of these things, it might be an interesting thing to build a PC board collaboratively and then have it sent off to China or whatever, JLM or whatever that company is that'll actually populate the board and send it back to you. It would cost like $5. Is there any interest in that?
Well, that's, you know, this is where you've hit a really, I think it is an interesting project. Okay. The problem I've always had when I've tried to do something like this, and I'm not saying, you know, professionally, you know, I worked on teams, but, you know, there was a lot of thought on how the tasks were and the interfaces between the tasks were designed so that, you know, like if I said, okay, you're doing module 16B, you know, you know what's coming into you, and you know what's going to go, you need to give out of it, and what's in between, you make 16B. And the problem with something like a PC board, that's 16B. You know what I mean? It's just, so whoever's doing the now we could do what could happen there is somebody could do a design review afterwards. And if there's anybody here with PCB experience, that would be really cool, you know, find out what they said. But, you know, I bet if I ask these guys right now, there's probably, I don't know, there's people here that use Eagle. There's some people who use proprietary, you know, they've got it at work or something. They use proprietary software. Some of them are using KiCad. You know, on the Gerbil level, they're all the same, but in between, there are pretty big differences. You know, the boards know that footprints, all of them are going to be named different. And it's all, I don't know. But it is something that I've thought would be a lot of fun. You know, what I would really like is to, poke somebody like Polo Lou or Pinaromi and ask them, hey, this is a neat chip. Why don't you guys make a module?
Well, actually, we've actually had some success with that already. So I probably, Kareem and I both had tagged Pimoroni, and they actually put out that near optical flow sensor that we pushed them to do. So, and I have a couple contacts at Pimoroni. So it seems like if I was to contact her and say, look, this is kind of cool, and somebody at the DPRG thought it would be a good idea, they might build it.
Yeah. Yeah.
We're creating a Java.
Hey,
Java
Murray,
library for that device right now.
Yeah.
Oh, you are? Cool. So see, somebody's already working on it.
Yeah,
That's
Murray, to
great.
be clear on one point, you talked about conflicting requirements. I actually had no requirements. I mean, the way I was looking at it was, I wanted to help you build a board because I would learn something and you would learn something. I wasn't necessarily a customer, quote unquote.
Well, the other person in that trio was Alexandra, the guy that's the mathematics instructor, I think in upstate New York or whatever. And he had the 12-volt requirement. So it would be just me and you. And there's not a third person, unfortunately. We couldn't even get a trio.
Yeah. Well, and that was, as I was pointing out, you can also take the approach of having multiple variants of the board. You could keep the driver hardware the same, and put a different MCU on it and a different variant, for example.
Well,
and everybody would learn something from the project.
I'll tell you what I think would be really cool about if a project like that is not so necessarily the layout of the sensor itself, but the layout of the protection and otherwise, if you look like at a typical Adafruit module, you can put the power in backwards, you can do all sorts of sense and it'll still forgive you, and that's the sort of, typically the reference boards from the companies don't do that. They pretty much say, well, we got 8 pins and here's where they come out on the board, and have fun with it. So you have to be.
Well, that's some of the things we were talking about too. I mean, on my own driver design, I've implemented reverse polarity protection circuit on my driver boards, and we were also talking about current limiting hardware as well.
And level shifters. I mean, there's a whole, there's a lot of, and like this, okay, so if you're going to have, the output's going to be I²C, how are you going to handle the pull-up resistors? Are you going to put them on the module, or are you going to, or if you put them on the module, which is probably what you would do, but you might want to have a jumper so you can disconnect them if you have pull-ups somewhere else and you don't want them to
all sorts of fun decisions to make.
Yeah.
Well, I have access to Altium, which is the newest version of PCAD, and have quite a bit of board design experience. So if you want me to review it or help you out, let me know.
Yeah. Hey, well, Scott, if you could look it up on Mauser and look up the evaluation module and then look up their data sheet, and then you can see they have their schematic, I think. Okay.
What was the part number again?
It's by Maxim, and it's a DS28E18.
Okay.
Doug, is there a lot of one-wire devices that you'd use on a robot?
One of the outputs of that particular chip is a one-wire. Otherwise, it's basically a one-wire pass-through. And I haven't used the one-wire that much. There was a time where the real-time clock, I believe, that I screwed around with one, but back from Dallas Semiconductor. it's for the case where it's apparently it has pretty good noise immunity, and also it cuts down the number of pins you need. I mean, when you say one wire, you always need two, because you always have to have ground. Yeah, I mean, ground has got to go somewhere.
That's $163 New Zealand. And believe me, if you live in New Zealand, that's just like 163 US. That's how much it would cost me to get that developer board. It's like, whew.
Yeah, well, no, nobody. I said I wouldn't. No, I
No,
wouldn't.
no. I got it. But I could buy a whole robot for that much.
Yeah. You could buy right now. You could buy at least two of the OAK-Ds, OAK-D-Lites.
Yep.
So
very cool.
Yeah.
How robust is one wire communication? So if you're using it around, typical robot connections, you got motors, you got encoders, you got all this stuff there.
I'm not an expert on that. I couldn't tell you, but it'd be definitely worth the internet search.
I mean, if I've understood correctly, like some of the cars, you know how the keys, it'll only work with the original manufacturer's key. It won't work with a copy. That's because there's a battery and or just a one wire thing inside there. And it's literally one wire. It's connected to the metal on the key. And when you stick that in the ignition, the ignition in the car is communicating through the metal in the key to the chip inside. So it's literally, a one wire thing. That's how I've understood it. So
yeah, in that case, they're using the body car for ground.
Yeah. So it's an automotive application. And I got to believe that, in that environment, what can you expect, right? It's not going to be super high bandwidth, probably. But if it can be made to work in that kind of environment.
I just thought it was an interesting part. Thought people ought to take a look at it, since we're always talking about how we're going to handle I2C and how we're going to handle SPI. And here's another way. So anyway.
Pretty cool.
Yeah.
Well, for somebody who had all this going on in the last week with 50th anniversaries and stuff, Doug, you covered a lot of ground. So
yeah, but windows and everything. God.
Yeah, good.
Okay.
I hate that.
So we got in queue, we have John G next, and then on deck, John K, and then Raj.
Yeah, this is my latest progress on going to this monstrosity that you see here is my latest conversion of my my Halloween robot spider from stepper motors to brushless DC motors. I've got this is my stack of 12 custom DC motor controllers. That's the business side where the motors and the encoders go. Spent all day producing this wire harness here on the back side. This is my, let's see if I can get the camera. There's my 3.3 volt logic power. I've got my calibration signal, and then my I2C coming out the side here. Whoops, blocking the view. So yeah, wire harness is a real it's a real pain to build. I still, as of yet, have to run the 12 volt power on these pins here. Oops, let's see. I always have a problem getting this thing in front of the camera. Yeah, these little 2-pin connectors here. That's where my 12 volt power goes for the motors. So yeah, this is a real rat's nest.
Hey John, your other spider's still going, right? You're not tearing your other spider up to get this spider, right?
Well, I'm pulling the legs off.
So the reason why I asked is, I looked recently at that robot contest that I told you about a couple weeks ago. I don't think the competition's that hard yet. I think you would have a really good chance, especially it being in October with Halloween.
The problem is I don't have enough time to put together a presentation of the level that I would need to. I mean, it needs to be reproducible from your instructable video, right?
Should be.
There's an awful lot of work that went into this spider, and in order to actually create an instructable that tells you how to build it would take quite a while.
Well, you don't have to have the super good instructable.
it would have, I mean, it could be.
You know, I mean, there could be definitely some. Well, here's what it looks like. You know, and I use 3D printing to make it. And my files are here. Boom. That's it. You don't worry about anything else. You don't say, well, you have to be careful about this and that and the other. I mean, you just have to give people enough that they would be interested in trying.
Well, maybe next year. If they have one
No,
next
I was
year.
going to say, you 2 years back, at least I remember the presentation roughly that you had. You had some slide decks for that. You could probably pull those information out from that.
Yeah.
Yeah.
I'm just saying, I think that's the perfect type of project for that.
Well, right now I'm focused on making it to Halloween. I'm building the linear actuators for the legs. Here's one segment right here with the motor wires. I haven't add the encoder wires there. That's just one segment. I need 12 of these. So I'm about halfway through that. You know, because when you look at the number of parts I have to print to put this thing together, I've got probably a dozen parts per actuator that I have to print and assemble and wire everything. So I still got a lot of work to do.
But John, you're going to have your new and improved brushless motor-based Halloween spider bot for this year's Halloween.
I should.
We're getting out of your way, dude. Carry on, because that last year's was awesome. You just got to finish this year because that's so awesome.
I can't wait to see how noisy it's going to be with all those. Because those stepper motors were pretty quiet. With up to 12 motors running, DC motors running simultaneously, this thing's going to whine.
It'll scare people that way better.
It might actually produce an interesting sound effect.
Eerie. Or it might just make the teenagers run away if you run the PWM high enough.
Yeah, I don't think I'll set up that ridiculous 2x4 frame that I have. That's just so much of a pain to set up. And I thought of drilling holes in the foyer in front of the door and actually put the motor that lowers it in the attic and just drill some small holes to have that fishing line come out. But nah.
Okay, John, I'm taking your last excuse. This contest ends in November 15th.
Uh-huh.
That's 2 weeks after Halloween.
Okay, I will consider it.
So basically what you should do is snap picture as you're putting this together, and then, because pictures are 1,000 words that people said, and that way you can use the pictures as the.
Yeah, I guess the reason I'm resisting because I'm kind of anal retentive and I want it. I would want to put together a perfect presentation with all the information, and I think that you're suggesting is I need to scale it way back, and then
because you got to remember it's got to be an article, okay?
I'm hearing John K. and Doug P. want to volunteer and help you do it.
Well, I don't have the camera to snap picture. Now, Doug could write the article.
Well,
but I'm suggesting pictures. As you build this, snap pictures.
And where do you submit where do you submit it?
Instructables.com.
Oh, that's easy. Yeah.
I'm just saying is you can go look at it. There's their robot contest. Like I say, if you're going to have this ready by October 31st, you got plenty of time. Just take, but do take
2 weeks afterwards to write, and before snap pictures.
Yeah, just every time you do something, take a picture. You can always cull through the pictures later, but it's really hard at the end if you suddenly try to make pictures of stuff you did along the way. So anyway,
very nice.
$500.
Well, as I said,
we look forward to that spider. That was just so awesome.
Because
hopefully,
if
hopefully
nothing
that few,
else, we would like to see the picture as you're building it, sort of the sequence.
Yeah, that's true too.
So
You can do it there. Hey, there's your November presentation if he's got it. Yeah, another thought.
well, hopefully within the next few weeks, when I have all the legs tested out and moving, at one of the meetings, you'll get to hear how loud it is.
That's
Cool. Cool.
that'll be good.
We'll sign you up, John. That's good. Okay. All right. So moving on, we still have a good 17 people online or so. So I think
I'll make real fast.
John K., what do you got?
Speaking of old things, new things, I bumped across this. So let me click a window. Yeah, we'll do it by window if I can find the right one. I have too many of these open. Yeah, so I'll show this one first. So this is back in 2018. They had this cute real cat that was also in the Maker magazine thing where you could laser cut it, right? So that was back then. And I noticed, as I was surfing today, I discovered that they have a new version of it out there. So let me click on the next window. Present now, pick a window. So, okay, yeah, that one. So, seemingly they have updated that robot to this one now. So they're actually out there in Inkwell, and it's like 200 something. But what it can do is, let me see, is this one? Yeah, okay. So basically, there it is, the new improved version, which is 3D printed, but so it's sort of cute. So if y'all been interested in it, yeah, because the old one was pretty good. So that's the sort of new version of it. So I thought that was interesting how they've changed and upgraded and how it moves around now. Yeah. So let's see. So yeah. So anyway, so there was that, as I said. So and it's super small. I was amazed at the size of that now. As I said, it's actually out there at Ingrel. So for like 200 something, they've had the. So let's see.
Pat, you did see it in the snow, right?
Oh yeah. Well, yeah. So you could walk in snow. So hey, for up in Canada, that will work well. I think
we only have 2 seasons in Canada: winter and construction.
So yeah. So yeah. So here it is. Now the one thing that was interesting, but that could be because of just the nature of the universe nowadays. I noticed that they has changed the date from January to May now. Back then. So anyway, so yeah, so it was interesting. So and they have a board out there, so I don't know. The board looks actually interesting. So and it's supposed to be open source bit, so may be interesting to go look at it more closely because they've been improving over the couple of years it looks like. So and there's how the parts look. Somewhere was somewhere in down there. So yeah, it's built by this custom bore that they have. So that was sort of interesting to look at. So yeah, and there's their 32 board bit. And they have Open Cat Co out there somewhere. So yeah, that may be of interest to look more closely at. At least I saw that and was like, because they had it in Maker magazine back 2 years back, and looks like they've been upgrading it since then, more than I realized actually until now. So there was that. And then the one other thing that Dub brought up that I thought was interesting that I saw. So let me, where the other window is. That was it.
I think the cat face on the first robot was better.
Oh yeah, well, I like the first one because it was laser cut wooden, but yeah, but they've upgraded from wood to plastic. So, and then he was talking about the Neil and Jason that. So there's this spot that looks interesting, and actually looks like it's well described too. So here's another one I would say that might be of interest to look at because, yeah, he talks and he has the semi and the whole bit here. So yeah, this is another spot that might be of interest. And then they do use a Python library for it and that. And then there's the power cell that they use because different voltages. So those were the three spots I saw that was of interest. And so, and this one's mainly because it looks like it's well documented and covered lots of different things. So let me go to the top. I'll run that moment after we ignore the ads. Or did I get? Yeah. Okay. Yeah, he basically built this because seemingly that was way outrageous, and so he was like, "I'll build a cheaper one." Where we get? There we go. So it looked nice, and used the relatively cheap $15 motors, which was sort of interesting too. It has the computer vision. So I would say this looks like interesting one for information. If y'all want to look at that more in detail. And, he talks about the board and stuff like that. So that's why I saw today that was of interest. And I've always been interested in the cat. And so eventually I want to build a version of the cat type thing. So that seems to be the future of robots is to get rid of the wheel and go for the legs. And I guess that's partially because you can walk in snow or whatever that way. And they have definitely improved electronics since the couple years back. So
very cool.
This one had. Let's go. And see, you're right. See, you compare back the 2018 and how they walk, and now what they have out there is just interesting, the difference between the then and now. So with that, I'll let y'all move on to the next subject.
All righty. Well done. Thank you. So next we had Raj, and then if anyone's after him, just get ready and jump in then. But Raj, what do you got this week?
I'll be quick. I don't have any robots that I built, but I set up my workstation. I got the table from okay, I'm gonna quick share on. So I finally have my setup. I moved here about 3 months ago, so finally coming around to setting up my workstation. So that's the table, countertop from IKEA. Legs were not available, so I got some other legs and some dryers and stuff. Starting to take out things from garage and putting it here so that I can start working. Apart from that, I pulled out my 3D printer and started assembling it. This is an old one, ANET A8 3D printer that I got probably 3 or 4 years ago. And now I'm starting to put that together. Hopefully it should be working by this weekend or probably tomorrow or something like that. So that's my update.
You're making good progress then.
Gold star.
That's worth something. That's
Gold star. Yes, gold star.
That's absolutely. That stuff doesn't happen accidentally, and it's sometimes not as much fun to set up the workspace as it is to build something. But you're building something.
No, the workbench gets 2 gold stars.
2 gold stars.
Last week we actually had a little metal shed. Remember?
That's right. That's right. Nicely done. Excellent.
Well, I have a comment for Doug. Where'd my phone? Oh. Doug, I thought about you last week because of your comments about driving your car with automatic cruise control. And I've been driving Prius, which was my wife's, but she got a new car, so it's my car now, which has automatic cruise control. And I've been driving it for since last June. But then it had to go into the shop to get some brake work done, and I didn't have it for 2 days, and I drove my old pickup truck. And I had to keep reminding myself that the cruise control would slam me right into the back end of that car up in front of me. It's not going to slow down. Further, because I think it is going to slow down, my body anticipates the deceleration, which then doesn't happen and feels like it's speeding up. So I'm kind of astounded at how quickly I got used to that function.
And you're saying it's worse because now people will get used to it, and when they have to go back in time, they'll have problems.
Well, that's probably no different than if you suddenly took away all the automatic transmissions, gave everybody a clutch pedal.
Yeah, but they couldn't move the car all that way. The other ways, yeah, and people hit you in the back end.
Let's say you've been driving for 10 years, and that's the only driving experience you ever had.
Exactly.
But of course the car brakes itself. Why? What kind of car wouldn't just stop automatically? Why would a car run into something? What's wrong with the car? When I have to hit the brakes.
I had forgotten that the way I normally would drive in my truck is that basically I'm adding and subtracting, mile an hour here and there in order to match the speed of the car in front of me. And so it's actually requires me to think about it and do something. And I'm just in this short amount of time, I'm out of that habit.
That was the thing that I thought, Dave, was the biggest change was how do you set your adaptive cruise control? With the adaptive, you set it at the highest speed you'd want to go. Well, when you're driving without, just regular cruise control, you tend to be just the opposite. You kind of like set it down near the bottom and then nudge it up if you've got a little more space. You nudge it down if it's, you know what I'm saying. So you're always nudging the speed up and down. So
whereas in the Prius, I just ignore it.
Yep.
There are some things about it that it's not perfect. Sometimes in a corner, it sees the car in the next lane and tries to slow you down. There's it doesn't do as good as a human. But I found that without really realizing it, I had come to rely on it and to quit thinking about it. And when I had to think about it again, it's because I was suddenly careening toward the back end of a pickup truck and the car was not slowing down. What's wrong? It's broken.
Hey, Carl, one last thing I wanted to do was to point out nobody claimed my 2.85 millimeter 3D filament. I have a lot more than I thought. I've got 8 rolls, not all full rolls, but probably 3 or 4 of them are full rolls of 2.85 millimeter filament that I cannot use with my new printer.
Does it fit in that pen?
What's that?
Does it fit in that 3D pen? Just asking. Somebody has the 3D pen. Maybe they could use it.
Oh, the 3D pen. Yeah.
No, the 3D pens are 1.75.
Right.
Yeah,
But the key is maybe you can make a pan that you eat for it.
Or get a new head for a 3D printer. That's enough filament.
I'm only gonna hang on to this for so long before I decide it's just not worth it. I'm just gonna throw it out.
Does the Makerspace have a head that big?
No.
Yeah,
No.
it's all the other one.
Well, that's the nice thing about going to the
You
new.
can put it on the shelf out there, but
Yeah, the nice thing
yeah.
about going, yeah, I could just one day, just drop it in, drop it on the shelf. Somebody will take it, right?
Take it to Tanner's. Oh, wait.
Why you got to bring up the old painful stuff? Hey, yo, what's up with all that?
Well, the nice thing about going to the new printer is now I'm at 1.75 millimeter, and it's a lot easier to get your hands on the right filament. So,
Hey, Doug, had you kind of experimented with the 3D pen? The pieces that you built, did they feel as strong as something that you'd get off a 3D printer, or were they substantially weaker? Or
It should be the same. The only thing, if you notice in his video, to like get the wall, he doubled the height, so he had 2 layers going.
If you're using a silicon mat, you have the advantage that if you notice it has like creases, so it's more like an I-beam. You see what I'm saying? You have deep sections and not so deep sections. So if you're using a silicon mat, it's probably pretty strong. That's why he was able to make a robot out of it.
Yeah.
If you're just doing it on a flat surface, it really depends on how you're laying it down. But I would say in general, it's harder to control and probably not. Now I watched another video by that same gentleman where he was using it was to eliminate screws in his robot frame. So like where you would use a screw, he'd have a hole, but he would just stick his pin in the hole, squeeze it up, and then kind of like make a rivet out of it. And so he was just eliminating, and that works fine if you're never going to take it apart. I mean, well, you know what I'm saying. So I'm not, but that intrigued me because sometimes I get too many screws. Now, I did find out one thing. I was really curious if I could weld, or actually, I guess you wouldn't call it weld. What would you call it? Braze. Yeah, braze. Could I braze 2 pieces of 3D of laser cut mason board?
Acrylic or something?
Yeah, that brown stuff I use a lot.
Fiberboard?
MDF?
No, it's not MDF, but
Masonite.
Masonite, yeah, Masonite. And Masonite is made by adding boiled linseed oil to paper fiber. And that doesn't really adhere very well to PLA. So you can't braze that type of stuff, or at least I wasn't successful in it. Because I thought that would be really useful, because then you could, with laser cut parts, you've got screws everywhere because you're using them to make your connections, your 90-degree turns and all. So if you could do something that just pretty much brazed it, you'd be really, that could be really, really useful. But it's still hot glue. It looks like if you're going to do that, it's still a hot glue type thing. And I can't control hot glue. I can't get it everywhere.
Plus, it comes apart in the back seat of your car.
Yeah. So anyway, so I'm experimenting with it. I tell you where I think it could be really useful is if you wanted to make a real quick plate, like you did. If you were doing that with 3D printing, you're saying probably 3 hours, 4 hours. With this thing, you could probably do it in 20 minutes, 15 minutes. So you might be able to, there are parts that it might be useful for. And the other thing he did is, instead of zip ties and stuff, he was just using, he was just tacking it and making a thread over it and tacking it on the other side. So there's, like I say, I was watching his videos, and I was watching them not because I wanted to build his robot, but I was interested in his fabrication techniques.
Right.
But you know what? Because you can call it fabrication techniques, but to me, it's 3D printing duct tape.
That's a good point.
What you could do is you could use it with like transparent filament if you want, and you wanted to make glossy lens for LEDs or sensors or something. You could then just paste it or intertwine it with the electronics, whether it be an LED or even cover wire with it. You know what I mean. So
that's a good. I like that idea of that you had of making a light pipe with it. You know, edge lit LEDs can really add some stunning effects. I don't know. I'd have to try it out. But there's one other thing too that I haven't tried that I'm real interested in, and that is trying some of the flexible material. There, it might because usually when you print flexible stuff, it's really thin. So it might really be useful for printing flexible parts.
Yeah, you might even then could do flexible light pipes and things like that. You could instead of having a rigid thing to guide light or to guide, maybe you can experiment.
Well, it'll be more organic, I think.
Custom head gaskets.
Yeah. I think you could do a lot with it.
Well, it's it's. I'm still kind of COVID. I was so busy and I didn't have anything, and it's really fun to just every once in a while to get some new toy and play with it, and that's what I've been doing.
After I hear you talking about it, it sounds interesting. I might get a 3D pen. I do a lot of 3D printing and demos and teaching 3D printing, and that would be an added fabrication capability.
Yeah. Well, like I say, I think somebody who's really, really good with it, somebody who's, I've seen models made of it, which they use to sell their 3D pins, that are really stunning, but it's way beyond my capability. But with a silicon mat, you can make all your basic shapes.
Well, I can see that you can actually print 3D forms that are guides, even vertical or horizontal. You could probably, print a structure that lines your hands up, kind of like templates. You can 3D print your own templates. Should you need to do this, of course, I'm throwing out what you could do without a use case, but templates.
Yeah. Well, if it, I'm blessed in the fact that I have 3D printers and a laser cutter. So if it's a plate, I'll laser cut it. I wish I had a CNC mill. In fact, actually, I do a little one, but it'd be nice to be able to cut aluminum plates. Like for example, if you look at Scott, all his parts are aluminum. He doesn't 3D print anything. It's all aluminum. David, I think, is pretty much, well, he uses Lexan a lot. So, but there's a lot more metal in the robots, and I think that looks intrinsically more professional now, even though 3D printing is truly viable as for prototyping. But you got to realize we probably only prototype. We never make the same thing twice. So unless it breaks.
Well, one of the things I've noted is that, there's a lot of stuff on YouTube where someone puts together things really quickly with hot glue or whatever, and it's great for a YouTube video, but and even with like the ExoMy robots, which are 3D printed, as soon as you get to a certain weight on a robot, you're putting a lot of stress on a lot of the structural parts. And yes, you can keep adding more and more plastic, but at some point you don't have a very strong robot, and that there's a certain limit to what plastic that's been 3D printed can do. Whereas if you're making something out of aluminum with stainless steel bolts, you could stand on that and jump on it. It's not going to break. And so there's certain parts of the robot, I think, that are entirely suitable, but for things like chassis and stuff like that, there are certainly 3D printed robots out there and some relatively big ones, but they're kind of more like demos. They're on the internet, but if they actually toppled or fell over, they might literally break. And that's not going to happen with an aluminum robot.
Right. Well, I will say this.
Might bend.
there are definite mechanical techniques to make your 3D prints a lot stronger.
I'm sure.
I mean, I've got some individual parts from even I have a, what do you call it? What's that little square that has all the little squares on it? A Rubik's Cube thing.
Yeah.
The guy puts it together, and the guy who made that model knew what he was doing. And those parts are really, really strong. Now, this 3D print, that's one possible, for example, you never have a line that just goes like this, a straight line. If you want strength, you use the I-beam effect. You come up, you hit little bumps on it, and you put little divots in it. Anything that breaks the line, and that adds tremendous amount of strength to it. And it also helps a lot with the lamination, but you often don't see that sort of stuff done with 3D printing. And then, that's one possible place where this 3D pen might really be useful is you could literally do an overbead, I guess, along certain weak axes and strengthen them up, because now you don't have a layer that way. Otherwise, where you're going around and around and around and around, the big problem is you can break it between the layers. Well, if you suddenly put beads all around the outside of it, that would make it a lot stronger. But like I say, you should never just go round and round and round. You should
but of course, if you think about it, though, no matter what you do with a 3D printer, you're not going to have something that's like, made out of aluminum and literally it's just about indestructible.
No, that's true. But do you really need that strength?
Well, it depends on what you're doing. If it's an indoor robot, then certainly if it's not going to be banging around except on a floor, then that's absolutely fine. But let's say what David does up in the mountains, there's not many robots that could take that kind of punishment made out of 3D printed plastic. I mean, a few sharp jolts, they'd probably come apart entirely.
I don't, I'm not sure I buy that all. It depends. You have to use it intelligently. If you're talking about in the steering mechanism, I agree with you. That's stupid to try to 3D print a steering mechanism.
Well, the entire XMI is 3D printed.
Yeah, but, that's what I'm saying. I have seen some that minimize the problem, but they're never going to be as strong as steel.
Sure.
But for example, like a tie rod, a flat 3D printed tie rod probably would be just as good as a steel one. So there are parts you could do because you're never using the weak direction. And I mean, if you did it out, and there are material differences. I mean, if you did it out of nylon, hey, you're never going to break it. You might bend the hell out of it, but you'll never break it. So I mean, there's some cool stuff you can do with 3D printing. I'm not trying to say it, but I agree with you. I like the look of metal. But here's another thing to think about. Since you can either CNC mill that crap, but there are three things you can do with a 3D printer that you cannot do with a CNC. I'm sure if you were rich and you really had what do they call it? One of those tilt angle 6, when you might be able to do it. But I'm saying that, 3-axis mill, there's some stuff you're not going to be that you can do with a 3D printer that you can't do.
Look at your typical 3D printer assembly. I mean, there's your perfect blend right there. They make the frame out of metal, and then everything else they made out of 3D printed plastic.
Well, yeah, I know. That's what I'm saying. It's a technique, and you can use it to its strengths. But I wouldn't say that you wouldn't. That has no place in an outdoor rover. I don't think that's true.
I also don't think it's true that indoor robots are not subject to lots of strains. What you're picturing is a robot running around on a nice flat floor and avoiding obstacles. Of You're not picturing it getting stuck up in underneath the chair and pushing as hard as it can to get loose and popping and breaking things while it does it.
I think the point I was
falling
making
downstairs.
I wasn't saying that nothing can happen indoors. I was saying that in those cases where a robot is not under stress, that a simply printed 3D robot could survive. But clearly, if you ran a 3D printed robot against the wall, it might snap. And you don't need a CNC machine. I mean, we've got like, the Go Build stuff. This thing, literally, it's 1.3 kilograms, and I don't know if I could destroy it if I tried. I mean, it doesn't flex. It's extremely strong. It's made out of aluminum, and you're not going to get me in that bloody 3D printed cult. I'm not joining. I just am not.
Well, I mean, to me, it's all just techniques.
I like metal. I'm like David. I like metal. Metal's nice.
Yeah.
Well, Murray, you can get 3D printers that print metal. I mean, they're additive manufacturing with welding equipment.
I can't afford one of those.
I'm just saying.
No, actually, those have come way down.
For welding cult members.
Those have come way down. So this was a couple of years ago now, so I'm sure the prices even dropped further. You can get you a metal sintering desktop kind of thing for just a starting price of around $110,000. It's pocket change, right?
I just hear the church bells ringing, man.
But another use which I think is underexplored, though I know John has done a lot of it, and that is lost PLA casting. You just melt your aluminum, pour it into a mold, and make as many parts as you want.
Yes.
So I mean,
that's another technique. Yes, I've done that before. I'm now into more the resin printer to print that and then do the casting.
Yeah.
That same concept. So
there's.
But if all else fails, you should get a laser cutter and then build wood parts.
Yeah.
I was just scrolling. I saw one for like $500 some odd I'm toying with. I don't know if you know this company, Doug. Speaking of that, so let me show you this because I'm like, wow, the price is interesting. So let me, go show you this and tell me if this is what you have or not.
No, I just have a K40.
Oh, I know, but that's why I'm like, wow, because I'm looking at it going, I may change my gears up a little bit. There was that CNC router cutter that's like $1,000 from up in Canada. I've been toying with, but I may change my mind a little because okay, yes, I click on that. So hopefully I didn't click wrong. But yeah, they have this one for.
Okay, well, you can do,
yeah.
I'd have to look and see what.
$529.
Yeah, what they put with it. That is a K40. Right. But I'm not sure. You have to see what accessories and stuff they had with it.
There's the accessories that people buy together is basically the water.
Well, that's well, for a K40, you don't really need that cooler. It's nice, but you don't really need it.
So you know this company? I mean, it looks actually interesting, but.
Put it in the chat, and I'll take a look. Okay. But you can buy it.
Yeah, they're based out of California, seemingly.
Yeah, you can buy a K40 for probably $300.
Well, that's what I was thinking.
Actually, that's on my thing to look at too. Is give me a laser cutter.
Yeah.
Simply because there's certain times I need to print nice big flat things.
Yeah. Well,
Doug, that's how you cut your masonite parts?
Yeah, I do that with just a K40 laser.
Right, and they seem to have a resource hub here that looks interesting. So as I was scrolling through, I'm like, everything you need about lasers and more, and light burn software.
Well, lasers are kind of like You always want one bigger and more
Yeah.
powerful.
Well, they have bigger ones. If you want bigger one, this one was like 500 some odd dollars. Their mid-range ones are like
Yeah.
that. So they start
Yeah.
around 2,000,
Yeah.
and then they
Yeah,
jump
yeah,
up
yeah,
to.
well, if that's really okay, wait a minute. K40 is going to be it's going to have a lot smaller bed.
Right. Well, it's only like
It's
8 by
probably
12.
yeah, that's about right. 8
And
by
then
12, 8 and a
right,
half
and
by
then
12.
and after that, their next one up is this one, which goes to 12 by 20, but it's also
Mm.
about $2,000.
Mm-hmm. Lightburn, I will say this: Lightburn is excellent software. If you got a
Yeah.
laser, that's what you want. So
Yeah, and it looks like their resource hub, as I said, is sort of interesting.
mhm.
Actually,
and,
yeah,
laser, and it's a very reasonably priced software too.
yeah.
I have a question, maybe some advice. I got the RFM69, so I've got a pair of these. It gets a Raspberry Pi 0W and an RFM69 radio transmitter or transceiver. I got a pair of them and running some Python code. And anyone had any luck with these things? I can't tell if I've got something wrong. I can't tell if I'm transmitting on one and not receiving the other, but I've got code that's supposed to basically ping back and forth between the two of them. I spent hours over the weekend with the bloody things, and I cannot get them to talk to each other. And I don't know if there's something like maybe one of them's not transmitting or not. Just
what's the name of them?
well, there's the LoRa radios, but the alternative to the LoRa ones are called RFM69. It's a different protocol. It's supposed to be easier to use than LoRa, and they come in different frequencies. And I'm running mine at 913 megahertz, I think it is. But they're an Adafruit product, and they sell 433, 8 something, 9. There's a bunch of different frequencies, and you choose the frequency from a number of frequency options. In my case, I'm just running it at 915. And so in software, you set the frequency, set everything up. It doesn't send any errors. It seems like I'm sending, I2C messages to the board. It's not throwing errors. It's all open source. I'm looking at the code. I put tons of print lines into the code and stuff like that. I can't see anything going wrong, but also don't see anything happening at all. And there's no evidence that it's sending or receiving. Black hole.
There's Adafruit Python libraries that you can use for those?
Yeah, I'm using the one that Adafruit, actually there's two of them. Adafruit has one in CircuitPython, which I haven't tried.
Mm-hmm.
And then I've got the other one, which is just the standard that you download from PyPy. It's a standard library for this particular series of boards. And, like I said, I can initialize the board. It pops up. I don't get any error messages or anything. And I can send messages, using this Python library to this board, and nothing comes back as an error. And yet I don't have any evidence that anything's actually happening.
Yeah.
There's no LEDs on the boards themselves.
I think the boards are powered up and everything because they actually,
they don't have
you send an initialization message to it. It comes back and says, it seems to be initializing and it's got power and everything, but there's not enough information coming back from the board that says anything's happening. So, yeah.
Can't you hook one up into a terminal, and just like real term or something and just watch it on your machine?
Well, I can see what I'm sending to the board, but unfortunately, once it gets, I've got, it's just a Raspberry Pi on the board, and I'm clearly sending messages to the board.
Yeah, but most terminals will actually have the ability to send also. So you can just hook one up. Now you're Linux. You don't have any Windows machines, right?
No.
I don't know what the equivalent in Linux is. But in Windows, I use RealTerm. And
I'm always on a terminal.
Okay, so you should have the ability to send from the terminal and probably capture, and also, so like a lot of times when I have two boards talking, I don't really. I have to have some way of checking them out. So what I do is I have one board and I have my terminal program that's on my computer, which in this case is RealTerm. And, like usually one won't send until it receives the corresponding command to send. So I have to ape that to send message and send it to the board, and then it sends back, and I can check it out that way.
Well, this has an acknowledgement mode where you can auto acknowledge or not. And like I said, I've actually got the software, the actual code, the Python code for the board. And what I've done is I've put print lines in it. And I can, for example, when I do a send, I can see it changing mode back and forth between receive, transmit. And you can say how many times. I say 3, and it'll do that 3 times and then time out. So I clearly am sending messages to the board, but there's just nothing after that. I mean, it doesn't send any errors, or the board's clearly getting the message and changing its mode, but whether it's actually sending out a radio signal, no idea.
No,
I mean,
but I mean, does the other board, wherever it's going to, where's the other radio? Is it sending back?
I got both of them right here. They're just sitting next to each other. They're exactly the same thing. They're both just a Raspberry Pi 0W and an RFM 69 board. So that's the little RFM 69 board right there, and there's the Raspberry Pi. And I've just got 2 of these that I've set up, and I've even got the same code running on both of them. And for some reason, I just don't get anything at all. It's just bizarre.
Okay, can't you do like a storage, like a counter storage, and just can't, so if it let them run back and forth, and if the count on both boards equals the same, that means they've been talking to each other.
Well, that's what I'm saying, though, is that there's no evidence that they are talking to each other. If like I just
not. Okay, so they're not. They're not talking. To
right,
each other.
right.
Okay.
I don't have. I mean, the software basically runs a loop, and the loop pings the other board and then receives back, and they both try to do the same thing. And then if they were to receive a ping, I would see that. I mean, like I said, I put print lines all through the code of not my code, their code. And so as it's running, I can see it trying to do things. It changes mode and it sends according to the fact that it sent, but there's just no evidence that it's actually going out over the antenna. And the only thing I can think would be to maybe wire up my oscilloscope to the antenna itself. But I don't have any.
You don't want to go to your probe would so swamp out your antenna that you'd never get anything real.
Yeah, that's true.
Yeah, really high capacitance.
Yeah, you'd have to be behind the amplifier somewhere.
You might try, though, just disconnecting the ground and waving the probe around near the antenna and see if it sees anything.
Yeah. Yeah, because I don't even, like I said, I don't have, the board is clearly powered up and it's receiving transmit and receive signals. Like, it's not receiving receive signals, but it's doing its ping and it's responding. It's not throwing any errors or anything like that in the Python code. But there's, like I said, no evidence at all that it's actually sending anything or receiving anything. So
can you add traps to your Python code?
I have, yeah. I mean, that is actually what the test code that I'm running is just a loop that from each side tries to ping the other board, and if it sees anything at all, either an acknowledgement message or the actual message being sent, it would print that to the console, but it's not seeing that. So,
do the boards have a visual light or something when they're acting?
No, but like I said, they're not responding with an error either. I mean, I can see the board actually in the Python code for the board, not my code, but their code. I've put a print line because there's a mode. It's receive mode, transmit, and standby. And so if I say send this message and send it, try 5 times, I can see it go transmit, receive, transmit, receive, transmit, receive, transmit, receive, standby, and then it times out. And so I can see the board responding, or at least the code sending to the board. I don't know if it would actually have an error or not, but there's just no evidence that the board's doing anything.
Well, you keep saying you do transmit and receive. How is it receiving if it's not doing anything?
It puts it into receive mode.
Oh, okay. But it never receives anything.
I don't. If it was actually receiving something during receive mode, it would show it, I think.
Okay.
But there's
so neither one are receiving.
No, I get nothing from either one of them, and they're running. Both are identical, in terms of. I mean, maybe I wired it wrong or something like that. But
are these boards based on that NRF 24L01 comment?
No, they're literally called. I've got a whole bunch. Here it it is.
Yeah.
It's
That-
this guy.
Oh, because I've programmed a lot of the NRF 24L01s. Similar, I guess a similar product, but
So yeah, that's the little board. And like I said, I've been really careful. They're not. I don't think I did anything wrong wiring it. But whether it's actually transmitting or not, there's just. It would be nice if the board had a little LED that said I'm transmitting, but it doesn't have anything like that.
If that's 915 megahertz, I wonder if you had a cheap walkie-talkie, you could hear static when it transmits.
Yeah, because I can set the
Good
frequency
idea.
from anything from, I think it's software settable, and there's 833 up to 915, I think it is. Whether
Yeah,
it's
I mean,
legal
you know,
in New Zealand, I don't know, but
FM transmitters pick up crap, and so I'm just thinking you'd hear
Yeah,
static if your frequency is the same. A cheap walkie-talkie with the same frequency ought to hear static every time you turn it on.
right, especially near the antenna, yeah. You get a harmonics even off that frequency.
Right.
I don't have a walkie-talkie, but I could try it.
Yeah.
They make kind of interesting little, waving devices, but at this point,
yeah, debugging RF, that's a whole different animal.
yeah, I know. I've never tried it before. I was kind of hoping it would just work, No, nothing ever just works.
You could build a little electronic 915 megahertz tuner in your lab there.
Yeah, I wouldn't need this then, would I?
The main problem with dealing with RF frequencies is trying to get them to stay inside the wires.
Adafruit has C examples too, right? Like in the Arduino IDE. I wonder if it's some issue with maybe with Python. I guess you could try it.
Yeah, I think that what I might do is, since I've been so lovingly successful with this in the last, I don't know how many hours, but what I might try to do, like you said, is just go back to the actual CircuitPython example and run the CircuitPython example as Adafruit publishes it and seeing if that would work, because right now,
yeah, they're not in C, they're in, they're not in Python, they're in C, but Random Nerd Tutorials has, they've got great examples for LoRa transceivers. That's what all these are now is, they're, well, I can't move it over there. It's an ESP32 with a LoRa transceiver and an OLED display.
These are the ones I'm used to dealing with. NRF 24L01 based boards. They have a SPI interface.
Well, this is a SPI interface as well.
Yeah, this board right here.
This is supposed to be easier than the LoRa. That was what's surprising.
Yeah.
So far, you cannot verify that.
I cannot verify that.
You didn't, you never turned it on without the antenna on it, right?
No.
Okay.
And you can put little wire. I have two of them.
Yeah.
Ray, does that burn them up?
They say it can.
Yeah, that's what I was thinking. You don't want to do things with antennas, is what I was under.
To run the transmitter without an antenna burns up the output of the transmitter?
Supposedly it can harm
that's,
it.
That's what I would think.
Yeah. It's the old standing waves.
Anyway, that was all I had. I mean, like I said, I'll try the CircuitPython example, but.
Do we have any hams in the group or any hams online today? Uh-oh.
So what does that mean, though?
You're hiding over there. What is
Very
the
much
gadget?
so.
What is the gadget that hams use when they're tuning their equipment where you fasten this thing on in place of the antenna?
Isn't that an SWR meter?
Well, that sounded very psychedelic, but I couldn't distinguish any English.
Yeah, I don't know why it's. Okay, it's a SW. I mean, a standing wave ratio meter or something.
Yeah, SWR meter. Dad used to use them all the time. I don't even know how to use one of them.
That's what you need. Find a New Zealand ham.
Actually, I know somebody who's a ham. was just talking to somebody who mentioned that they have a ham.
Well,
intro.
they would have the equipment. They could just hold it up in the air and say, "I see a signal" or "I see no signal."
But
Unfortunately, I just remembered the guy that I know him from the Discord group, the chat group, and he lives up in Hamilton, and I think he's behind the other side of the pandemic boundary. I don't think we can talk to each other. And it's also a long drive. It's like 9 hours up there.
I mean, the other thing is,
how bad do you want a signal, man? I'm just saying.
If you want to drive 9 hours on a 2-lane road with no barrier between, good luck on it.
You got to do what you got to do, you know, for the love of the hobby or something.
Yeah, on the wrong side of the road, no less.
And it's going to have a bursty packet transmission format, right? It's not going to be some continuous waves. So
no,
that means you're going to need, I think, you're going to need protocol-specific equipment if you want to measure it in the RF domain.
Well, can you find out?
Like, right? This whole video call is turning into like kind of a drug trip.
Well, can you find a forum where they discuss the use of these modules?
Well, there is the Adafruit forum, and I've looked online, and I can't. Yeah, there's nothing that's helpful so far. But you know, this is not a high priority in my life. Getting these to run is after I've got my Mars rover up and running, and I want it to go down the street. That's when this becomes important.
Well, I think you had a good idea on just trying their code without making any changes. Maybe you fucked some.
Just to prove the board works, yeah.
Marie, I just did a Google search on cheap SWR meter. And there's some on the order of $26, but here's one from SparkFun for $4.95.
So that plus $130.
And I even have a SparkFun cart with stuff in it, maybe. So I look for SWR meter.
Yeah. Look for cheap. Look for cheap SWR meter. That's what I searched on.
In SparkFun.
No, I just Googled cheap SWR meter.
Oh, okay. And it turned out to be in SparkFun. Okay,
yeah.
Cheap SWR meter.
Yeah, the only time I've ever seen those used, that was when Dad, he was a big CB'er, and he was a bit of a ham as well in all sorts of ways other than the radio. But literally, people would come over on a Saturday afternoon with their CB radios, and they start hooking up the stuff and start adjusting lengths of their antennas and all that kind of stuff, so they could get, you know, it was, they were just geeks. They just didn't know it about CB radios and antennas and things. Now that I look back on it, I'm like, I should have gotten more into that. That was pretty cool.
Yeah, I found some on Amazon, but I didn't find any on SparkFun. But there's one for $32 plus shipping to New Zealand of $370. Typical Amazon. I'm not falling for that crap. No way, man. Oh well. I did put in my last order for parts from Servo City. I've got the rest of the parts now for my Mars rover on the way. So it's not actually a Mars rover. It's a 4-wheel steering robot. It's a precursor to my Mars rover, but all the parts are on the way now.
What is your typical delivery service to New Zealand? Is it a guy in a canoe or something?
David, Andrew, could you mute? I think you're echoing us.
That sounds so cool.
Thanks.
Who's creating the echo?
David's speaker was getting it back to him.
Oh.
Now that he's muted, he's trying to tell us something.
And it's very important. I'm sure that David's going to tell us something really important.
He's got all kinds of talk.
Oh, I'm just moving my mouth.
Yeah. I'm trying to think. That's about it. That's about it from this end. I've got all sorts of things going on, but nothing like this swerve behavior I've almost got running. So the two oblique analog infrared sensors now send out a single message, which is how far to swerve on 2 lambdas. And as soon as I've got it, I got a bug in it right now. My motors just go to 100%. But once that's going, I'll be able to actually set the robot on the ground, and theoretically it would swerve away from whatever is the closest thing. So we're getting there. It takes a long time to write an operating system.
Yes. So in this silence, I have a complaint I've been waiting to make.
Uh-oh.
And I was thinking about sharing my screen, but I'll just talk about it. Way back when I first started coming here, I was talking about my HARP robot that was going to go around the house and get kicked over by burglars and all kinds of stuff.
Yeah.
And, you know, it's still on one of my projects, like Carl was talking about, on my wish list. And darn if Amazon didn't come out with a new robot the other day that does half of what my HARP does, and they're charging $1,000 a piece for them things. Anybody see that article?
No.
It's got a cute little screen that makes
the spy robot. We talked about this.
Yeah,
It's,
the one that you put in your house, and it basically tells Amazon all the products in your house and when you're home and where you live.
Yeah,
and,
one of those.
Yeah, great idea.
So Alexa now follows you. At least on my Alexa over here, I can leave the room and they can't follow. But now,
Yeah, this one will follow you into the bathroom. Even, I mean, just what you want.
and be all cutesy, winking at you while you're trying to go to the loo. It's just
Pictures
crazy.
of me on the toilet posted to the internet. Great.
Hey, you know, if somebody digs that, that's fine. I'll make $1. I don't really care. You know, but I can't imagine.
I'm just upset that they're selling for $1,000 half of my idea. Since I posted it on the internet, clearly they've been reading my blog.
You should go after him. You should get a ride up into space with Bill Shatner.
That's all I had.
All right. That's cool. Okay.
Well, I see Chris has already signed off, but I was going to tell him that seeing his presentation about his documentation last week inspired, or maybe a better word is shamed me. And so I've been working on documentation for the last week. But, you know, he did a simple thing, and I don't know why I've never thought of it. You know, I have these ASCII texts, and I have ASCII drawings of the boards, and I use lowercase o's for the pins and everything. He just got pictures of the boards. That just makes so much sense. I feel so stupid that I never thought of it.
Well, it's hard to cut and paste a picture when all you have is a QWERTY keyboard. But now you have more than a QWERTY keyboard, so don't kick yourself, man.
Well, one of the things I've been doing actually, which works pretty good for me, is I take a photograph, and then I'm sure you guys know what Inkscape is. It's a open source SVG editor, a graphics editor, and it's a object editor, so you can make lines and things like that. But it doesn't do raster, it doesn't do what Photoshop does, and it's open source, multi-platform. So what I do is I take my photograph, import it into Inkscape, and then I can put lines and dots and text on top of it. So I would take a photograph of my board and put dots on the things that were important and put text next to the dots, and then you save that, and that's your documentation. That works pretty well. So you kind of combine the ability to have text as a layer on top of a photograph.
I think my observation with Chris was just that he was doing documentation.
I found I have to. I look at the inside of this robot, and there's a whole bunch of wires. I mean, God, I would have no idea what's connected to what otherwise. Like, I make a wiring harness that has, you know, like, God, I won't even pull them out, but I've got wiring harnesses that are they look like they're coming from NASA. You know, they got wires going here and that way, and
They look like John's wire harness, don't they?
Yeah, and you got a wiring harness. You need to document.
That's a wire harness.
Exactly, John's got it right there. If he doesn't document that, he's screwed. But documentation, oh my. I'm a software developer for a living. I'm supposed to do that all the time.
It's hard.
And boring.
John, your mic's off.
Your mic's off, John.
It's the anti-echo.
Oh, sorry. I say I definitely have a scheme for that, you know, a color scheme. Gray is always clock. Green is usually data. Yellow is always 3.3 volt supply. Of course, black is ground. Red is anything other than 3.3 volts. So, yeah, I've got a scheme there to keep everything straight.
What I find is that there are lots of small things that I actually never really think about, and therefore I don't really think about documenting. And then when I come back to the thing a year or two from now and look at it, those pieces are like, oh, you know, like, what's the sequence for doing a download on this microprocessor? How do you put it in download mode? I do that dozens of times every day, and so it never occurred to me to write it down. But I sure as hell don't remember it.
And you can't see it because the camera is too close to focus on. But everything on my board is always labeled on the back, and I even have the mounting dimensions for these holes on the back of my card. So
John, that's almost anal, John.
It
I think
is.
you were, yeah, exactly. I think there was the word anal didn't come into that.
Yes, you know that, don't you?
But it's better too much documentation than not enough. So I applaud you on that. Amen.
Yeah, I can't count the number of times I wish I'll say I come back later, like you said, to a project and go, I wish I'd have written that down.
And it's
David, there's
especially
one thing-
valuable if the marking on the board is correct. I hate it when it's on the board but it's wrong. I've done that.
Does anybody here remember blue wires?
You mean wire wrap?
Not the whole board, just the parts that you found out you did wrong.
And dead bug parts, yes.
And how about a 8-pin chip glued upside down on its back?
Dead bug. Yep.
Ooh.
Yep.
Dead bug. I've never heard that. That's
what we call them,
They
David.
look
And
like
that's-
dead bugs.
And I can assure you that there were in my day, there were production military defense electronics circuit cards to government agencies in fielded tanks, which had dead bug parts, blue wires, and conformal coats so that it would be okay in the nitrogen purged housings. Yeah.
Absolutely. I remember this years ago, getting some new cards and putting together this system. And I was talking to the engineer, and they had these blue wires on the back. And I said, those make me nervous. And he said, oh, no, that means they work. Somebody took the time to make it work.
Yeah.
Well, I think you call them blue wires. They're actually very, very thin insulated wires, right? That are colored blue. Yeah, that was the typical color of wire wrap boards.
Yeah, and it's not really a jacket; it's a coating.
Yeah, way back when I first started working at E-Systems back in the mid '80s, all their prototype boards would be wire wrap. You know, and we're talking about sometimes thousands of wires on a single board.
But those also it turned out to be convenient construction material if you needed because at least the kind we had back at TI, Defense Group, you could solder pretty well. So it'd strip well. And I think in that case, it wasn't just coated, it was an actual insulated.
Yeah.
And you would solder it at each end. So it was, you break the wire up wire and solder it because that's what you use wire up wire for.
So it's because on these boards, pin 3 and 5 should not have been grounded.
Right.
Well, David, you'll be happy to know that I'm now buying an STM32 board.
Oh, those are nice boards. Which one did you get?
I haven't ordered it yet. I'm kind of up in the air. I've been talking with John about this idea of a motor controller and whether we would put the PID controller, the encoders, and everything that's sort of RTOS on one board or on 3, because eventually I'm going to have 3 pairs of motor controllers, or 3 motor controllers, I should say. So the question is whether one board can handle it or not. So I'm kind of leaning towards the Pi board, actually the ZO Pi board. So, because it's got, I think it's like 12 ADCs on it or something like that, or 20 maybe. It's got a lot of them.
I will say I really like those STM boards, but they're getting a little long in the tooth.
Well, the new, the ones that are out there, the Pi board now has a 168 megahertz chip on it, so it's plenty fast. The Pi board, the STM boards, the ST Micro ones, they're slower, like an Arduino, aren't they? 16 megahertz or something like that.
No, they're 100 megahertz.
Oh, okay, all right.
What do you mean long in the tooth, David? Do you think it's getting old technology that's being displaced by something else? Or?
Yeah, smaller cards with more memory and faster processors and that sort of thing.
Well, the Pi board is kind of an oddball board, and there's a company called ZO that puts out a purple version of it that has the stemma connectors, but it's the same board basically. And I've thought about that. Then there's the SparkFun. They have this MicroMod series, which is they have a processor board. I think I might have talked about this last week. They have a processor board that comes in like 6 or 7 different MCUs, and then you choose one of their like 6 or 7 carrier boards. And that's still an attractive proposition, except for the fact that only one of their carrier boards fronts up all of the pins on the STM32, and that's called their ATP, all the pins board. And it's kind of big, it's about that big, and that's not big for some people. But if I'm going to have one of those on a small robot, it takes up a lot of space. Whereas the Pi board is, it's tiny, it's about that big, and it has all the pins on it. So I'm kind of leaning towards that, and it's $40. And I've never tried an STM32, and it is the only reliable I2C slave board out there in MicroPython. So I think it's time to bite the bullet and try one and see how it goes.
Now, when you say it has all pins, those ARM processors, depending on the mask, the device itself might not have all pins. So, for example, you have these ports, A, B, C, D, E, F, so forth. I think on most of those boards you get A, B, C, and one pin off the D port for reasons unclear to me. But there are more ports than that. It's just there are no pins. But on some of those chip masks, there are those pins. So, for example, when I moved to this latest version that I'm using at Dave Ackley's suggestion, it's because I wanted to have 4 UARTs. And this particular mask allowed for that.
Well, the way I'm looking at it is that I had been buying all these little, what were they? The tiny Picos and stuff like that, thinking that would work. And then I bought 4 of them even. And then I found out that they don't support I2C slaves because they're ESP32s in MicroPython, to be clear. And
peripherals.
Yeah. But the STM32 as a chip seems to be where I'm going to head, because I want to program in MicroPython. And so there's a couple different options in that category. And like I said, the micro mod is a nice STM32 little tiny board that you put onto a carrier, but it doesn't front up all the pins. It fronts up a lot of them, but like you said, they're all different. And it fronts up fewer of the pins, like fewer of the ADCs, for example, than the Pi board. The Pi board, depending on how you count, has like 20 ADCs. And I don't need that many, of course, but the idea that the Pi board has that many pins available to it for $40, it kind of beats out the competition.
Basically, I think that any one of those I/O pins can be specified to be an input pin or an output pin, or an A to D input pin. Any one
Not
of them.
all of them. I think not all of them, but on the Pi board, there's like 20 of them, so most of them. Yeah. And the thing is that the target here is the idea of having, for the Mars rover, which is going to have 3 pairs of motor controllers, and 6 wheels with steering, although the steering servos would be something else. But I want the encoders, so that's 6 motor encoders, 6 PID controllers, and the ability to control that as a slave, an I2C slave in MicroPython. I think that would be all doable on a single board. It's 168 megahertz, and as long as I can count 6 encoders accurately on 6 timers, basically. No, they'd be interrupts, so it wouldn't be timers. But 6 interrupts plus the PID controllers running, I don't think that's overloading a single board. It should be fine, rather than 3 boards.
I don't think you're going to run out of CPU cycles.
No, not from what you've said. It sounds like it'll be fine. And if I can do basically the whole robot with 1 Raspberry Pi for the high level and the Wi-Fi and all that, and then this Pi board handles all the RTOS level stuff, then that's it for the whole robot. That would work fine.
If you look at that on that board, if you're wanting to play with the A to D inputs, the really powerful way to do that is to couple that with the DMA controller, which is actually built into the same hardware. DMA controller can automatically read the A to D converters and reset them and put them in a little block in memory somewhere. And then all you have to do is read that little block in memory.
And that's on the STM32 already?
Yeah, you can look at the, what's it called? The Cube 32. Somebody tell me, what's the name of that library?
CubeMX?
No, it's anyway, their library supplies those functions.
Okay, cool. Thank you. I'm kind of looking forward to it because it looks like a really interesting board, and I haven't been down at that level for a while. I know that's where you live, is on that STM32 board.
I will say that the features like that, like the direct memory access controller, the memory controllers, there's a nested vectored interrupt controller. These are big dog. This is the kind of stuff you'd expect on, big, powerful processors. And for us to have access to that kind of hardware on a little tiny $3 microprocessor is kind of stunning, really. It also means that you can spend months on something that's, an inch square.
I look forward to that.
I put a link for the IDE in there, David. It is the STM32 Cube MX.
I better get a link off that quick.
I think it's an IDE. David Ackley showed it some couple years ago, and even I think, as I remember, if all you do is look at the IDE as a documentation tool, it's pretty cool.
Uh-oh, I've lost I can't find the tab you guys are on. I'm looking at tabs. Oh God. Oh, I've lost us. Oh, there. Okay, I'm back again. So, but that's probably something that only runs in Windows, right?
No. What he's talking about is an interface. What I'm talking about is the library that interface, and it's called I'm looking at it right here on my computer, STM32 Cube.
Yeah, okay. Yes,
and
okay.
And they've got basically code that's, it's standalone, but you can use it as the starting place for your drivers.
Cool. All right. Different world than I've been in. I thought you might be pleased to hear me kind of digging towards you in the tunnel.
Now, the next step would be when you start digging with the language C.
Oh. I haven't programmed in C in over 20 years, David.
Well, it's time.
I've been enjoying Python. It's actually kind of fun. It has its limitations. But I've done a lot of Python coding. Boy, I've written a lot of code. Half of it works. Can you do multi-threading in C?
You can do multi-threading with an RTOS.
Yeah. You're relying on the hardware.
You can write in C. If you'd like, I will send you my STM32 RTOS.
I'm going to stick to Python. I've got a huge investment in it now. Like, what? How long have we been chatting, old guys? But
couple of years.
So I've got about 2 years of coding into this now. And it is functional. I know I'm going to get a little razzing from you guys no matter what I do, but
if you could only 3D print in C.
Whoa, isn't that called OpenSCAD?
Well, I've been programming in C virtually my entire career. I mean, 33 years as a software engineer, and I think probably 31 of those have been in programming in C and C++.
Well,
but I just picked up Python here about a year and a half ago, and I really like it.
So when I'm referring to open, the letter S in CAD, it's functional programming to develop 3D models that people print with, and you do it in code.
Well, like I said, I haven't programmed in C for about 20 years. So I think it was like 19. My last big C++ project was 1996 or 7 maybe. So it's been a while. And that was on Microsoft too. What was the Microsoft IDE called?
Visual Basic.
Not Visual Basic. Visual
Studio.
Visual Studio. Thank you.
Oh.
In 1997, I was writing robot code in Forth, which was the Python of the day.
Guess what?
It's a fourth assembly, a fourth language that I wrote myself in assembly language. And then I got in touch with Randy Dempsey here, who had 6502 modules with Forth blown into the PROM, which was pretty cool.
I love Forth. Turns out there's a guy in Hamilton. It's this guy I mentioned before that I met on the chat board he's a Kiwi, lives up in Hamilton, and he's writing a Forth compiler for the RP 2040 for for the little Raspberry Pi chip, Pico chip. He's writing a fourth compiler to run a keyboard, but he's potentially going to open source the fourth compiler. So
I have written probably a dozen fourth compilers on different pieces of hardware, and I'll just say I've moved beyond it. There's a lot of things that an interpreted language like that, which is what Python is, makes easier to do, but there are a lot of limitations. And I found that that I could do all those things more efficiently with smaller code that ran faster in C.
I think we should all convert over to Lisp.
No. I think you guys are going in the wrong direction. If you want more efficient and faster, then let me tell you, in '97, I was writing Xilinx and Altera FPGAs in VHDL. Now that's fast.
My God, you're earning brownie points in heaven for sure. I will say I've looked at Rust. If I was going to move to anything else, that is the most intriguing for me. But also, I'm interested in operating system level stuff, and you need
higher level.
There are different requirements.
Yeah.
Well, there is a language called Clojure, which is actually a Lisp that compiles to the Java JVM. So it's entirely compatible with Java libraries. So you can run it in big infrastructure systems, but you get to run basically Scheme or Lisp-like code. And I probably am going to have to learn that in the next year for my job. So, but I haven't used Scheme in like 20 years either. So
well, you should keep us updated as you progress through that.
That's the modern version of Lisp.
Yes, it is. And the nice thing is it does compile. You can open it up in Eclipse IDE and compile it with all the nice Java libraries. That, there's thousands of libraries out there that are really good. And you can integrate Clojure code that does the Clojure side of things, like the Scheme and the whatever you're using that for, with the more lower level stuff that maybe integrates with your hardware or whatever, or your networking or whatever else. So it's going to give me a chance to play with some of the kind of AI type of stuff that Clojure gives you.
They're still teaching Lisp. My son is taking an AI class in college, and he's doing some Lisp homework
60
right now.
years later.
It's amazing.
John McCarthy, 1958, right?
Staying power.
I can see that, though. It's sort of like in music school, we had to study 17th century counterpoint.
It's true. It's almost archaic in a way, but
Well, it's important to learn how we got here.
Yeah, it's true.
But what's remarkable, actually, is that you look at Clojure, you look at Scheme, and you look at Lisp, and there's almost no reason to change it. It actually does exactly what it was designed to do.
Mm-hmm.
Well,
So
you
you
won't
don't
be
need
able
to
to tell
change
that
the
to
counterpoint.
language designers, but yeah.
But I think David's point's correct. It's like looking in music. There's certain things that were just done a certain way, and they work, and they are a way of communicating in music or in programming language, a certain thing. And Lisp does exactly what it was designed to do. It doesn't need to be expanded or anything. It does exactly what it's designed to do. And therefore, 1958 isn't very long.
Well, everything that is executed properly does exactly what it's designed to do.
On the other
It's a bit of technology, but
Kareem, you have to think about, basically it's a Lisp processor, right? That's where the name comes from. So the question you have to back off from is Lisp processing what problems is that the most efficient way to solve?
I remember being in college when a lot of the students I was hanging out with discovered that technical students discovered Forth, and it's like, whoa, like they were just like, this is the best thing since sliced bread. You should learn how to use it.
It was pretty cool at the time, but of course the reverse Polishness of it all makes the code real hard to read. And the fact that it's an extensible compiler basically means what you do is you add functions to the compiler one by one until eventually one of them is your entire program. And so what that means is when you sit down to read the code, none of it makes any sense. You start at a top level and it's all defined by words you've never seen before that have functions you don't know. So you go and read each one of those and they're all defined by words you've never seen before that have functions you don't know. And when you get down into the depths of it, they've made this weird extension to the compiler that uses builds does and automatically compiles a whole new structure type that you've never seen before. So it's real hard to read the code from the top down. You basically have to read it from the bottom up when you don't know what it's trying to do. The problem with Forth is because it's interpreted, it's slow. And there are arguments. Basically, this is me. Forth was an intuition of object-oriented programming before object-oriented programming had been developed. If you look at the innards of Forth, you have methods. You have data objects associated with the behaviors that operate those. Copy to the stack, print to the screen, add to another variable, and so forth. So each word, which is what procedures are called in Forth, each word consists of a data structure and a list of pointers to executables that can operate on that data structure. So in that way, as I say, it was an intuition of, but not a full-blown implementation, but it was an intuition of object-oriented programming.
Sounds like a code optimization tool.
By the time you get to, there's a lot of cool things. You know, it was designed to handle the Keck telescope. That's why Charles Moore wrote Forth. And as long as you're doing things down at that level, it's suitable. But it's not suitable at all for a big, complicated software program with multiple people involved. It just becomes a nightmare.
Well, that's true, I think, of Python as well, is that for what I'm doing on a single robot, it's fine. But what I do at work with, 50 people and, we've got I worked on a thing for the New Zealand police I might have mentioned a few years ago where I edited about 1/3 of a million lines of code over 12 months.
Good God.
And that got checked into master. I was very proud of that work. But, it's a huge system. And with 50 programmers, well, not just programmers, 50 people on the team, which is about 1/3 of them are actually programmers. You got project managers and everything. But there's a lot of people working on that code. It's all in Java. There's no way you could do that in any other language, really. You couldn't. You could possibly do it in C, because like Microsoft Word is written in C. And they had 1,800 people on that team, by the way.
Honestly, almost every operating system and every computer language is written in C.
Yeah.
I rest my case.
And most of those are nightmares too.
Yeah, but the point being, for any language that you use, you can always write a bad program.
Oh yeah, it's pretty normal actually.
I'm pretty good at that.
Likewise.
I don't know if you guys ever worked in Fortran back in the day, but there were standard practices in Fortran, which you may well remember. There's the way memory was organized was what was called a common block. So you could put a bunch of arrays in the common block, and then you could index into all of those arrays just starting at the beginning of the common block. There was nothing that kept you from overflowing from one to the next. So, okay, cool, right? Well, no.
That's how you could hack and write to the system console.
Oh, there's all kinds of reasons that's a terrible idea.
Yeah.
But that was the way we did it. That was common practice.
Well, when you say worked in Fortran, actually that was we were using Fortran at college back in the early 80s.
Yeah.
And everybody remember punch cards?
Yeah.
And the old IBM KP29 punch card machines? Chook, 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 chook.
Yeah.
Well, also those. I lost my train of thought, John. You made me laugh.
Derailed you.
The scientists that I work with, the geophysicists, still use a lot of Fortran. They don't write code anymore. They all use MATLAB. But they link to all these Fortran libraries. And the reason is because there's so many scientific libraries out there in Fortran that can do some pretty amazing, pretty deep stuff. And it's optimized and, has been developed over the years. But when I first went to work at SMU, the physicists and the geophysicists all wrote code. And none of them write code anymore. That's not part of the job. They, as I say, they use MATLAB. That's the closest they get to coding.
Well, when I was at the New Zealand Weather Service, the whole research team was using and writing stuff in Fortran, and we had to, get cross compilers to get it across into the regular systems. But they like you said, there's plenty of stuff out there. There's no reason to abandon it. It works. It does exactly what it was designed to do.
Furthermore, if you look at modern Fortran compilers, like the GCC compiler, what you'll see is that it creates a data structure from the Fortran input and passes that data structure to the C compiler. So even the Fortran compiler is, in point of fact, a C compiler.
Yeah. I can't go better turtles than you, David. You got...
Okay, you guys.
Anyway, I gotta go.
It's turtles all the way down.
Yeah, it's turtles all the way down to C. Or no, assembly.
Much better.
Take care, guys.
All righty. Yeah, it's getting late here too. So everyone have a great night. We'll see you Saturday. I don't know what the topic will be, but we'll have a good discussion.
Yep.
Take care
And
now.
time, 1 o'clock or when?
Yeah, 1 o'clock.
Okay.
Yep.